Welcome, everyone. This is Mike Gibbs and the team at Go Cloud Careers, and we are here for a completely free AWS Solutions Architect Associate Bootcamp. This is our summer AWS Solution Architect 2024 free bootcamp, and this bootcamp is going to focus on getting you guys and gals out there through the AWS Solutions Architect certification. We are going to have all kinds of fun over the next 2 weeks. And we're really going to make sure that you get through this AWS full course tutorial and that you get this free AWS certification training that we told you about. So, here's the key. We're going to make this a course where we really want you to learn. I've been in technology now for over 25 years as an architect. I've been a cloud architect, a network architect, an enterprise architect, a business architect. And not only have I worked for about 25 years as an architect, people I've trained or coached over the last 20 some years are now working at Apple and Amazon, at Cisco, at Microsoft, Google, Accenture, Deloitte, KPMG, Capgemini, PricewaterhouseCoopers, JP Morgan Chase Bank, Barclays Bank, Zscaler, Palo Alto Networks, and every other prestigious organization you can think of. So I want to really help you, and I want to make this a really good boot camp for you. So in this free AWS course, I'm going to let you know the flow. We have approximately 3 hours per day of this AWS Solutions Architect training. And we're going to do this from 2 to 5 p.m. for 2 weeks straight. Additionally, after this is over, we're going to do some hands-on tutorials for you and live tutoring. We want to make sure you get some feeling for the systems that we're talking about. And our team has about 40 to 50 labs for you. And these are good labs for you to get some hands-on experience. I want you to go through these labs. I want you to work these labs, and I want you to get hands-on. But we're going to focus this time on teaching you the technology. What is the technology? How does that technology work? And why you should use it. So not only can you easily pass this SAA-CO3 exam, but at least you are able to work as well. Because when I interview people or any technology professional interviews you, they ask you about the tech it is. And if you can't explain what it is, how it works, and why you would use it, no matter how good your skills are at clicking a bunch of boxes on a management console, they can't hire you. So let's get good training time. Let's get some good education, because I want you to all love this. I love working on the cloud. I've been working on the cloud since 1993 with the ISDN cloud, 1996 on the Frame Relay cloud, 1999, 2000 on the BGP cloud, and then the VPLS cloud, and every other cloud there's been. So I've consulted the cloud providers on how to design their clouds for decades as well. So I want to make sure this is free AWS course is great for you. And this is, again, a full AWS course tutorial. So let's get on with our free AWS course training. So before we begin, I want to know where you're at. So tell me where you're at. I'm over here in South Florida today. And I also want to tell you about a guide that we've written for you. We have a certification guide that you can use to maximize your career opportunities. Certifications are a very powerful way to build your brand, to get employers to want to talk to you. And if you build your brand the right way as a strong, focused brand, you will have more opportunities than you can think of. Sadly, most people do crazy things with their certifications, and meanwhile, they work so hard. I mean, truly so hard to get to their goals. And in the end, they spread themselves too thin learning other people's careers. So we've got a certification guide that's going to help you say if you want to be a cloud architect, and it's going to be focused on everything you should do. I love this. I see South Florida. I see Mississippi. I see California, Houston. I see UAE. I used to work in the UAE. I kind of loved it over there. Philippines, which is great. I see Kenya. I see Nigeria. I see Toronto. I see India. This is great. New Jersey. I lived there for many, many years. And I see all kinds of great places as well. So wonderful. Love it. I also want to know that you are awake and you're ready to get started. So please give me a hashtag AWS Solutions Architect Associate. There's about 230 of you, and I see a bunch of that. We will begin and we will have some fun. We are not only going to just talk about the materials in the Solutions Architect Associate course, but we're going to talk about the technology. When we talk about virtual machines, we'll bring you back to our data center and show you what it looks like in the original way. When we talk about databases, we're not just going to talk about the stuff AWS supports this and this, this and this. We're going to talk about those individual databases and their strengths and weaknesses and what they're used for, so you know how to design your systems like a cloud architect or a solution architect will. And we're going to get involved into Kubernetes. We're not just going to talk about the AWS service, which most people would do in about 5 minutes. We're going to spend an afternoon and really talk about Kubernetes so you understand it. So we're really focused on getting you great. So I hope you enjoy this. If you're willing to hit the like button and signal other people to come here, please, great. And if you enjoy the content, please go out there and hit the subscribe button and hit the bell and maybe even invite a friend, because it costs a lot of money to put these together. But the team at Go Cloud Careers really wants to know that you guys have the best opportunities in life. And after sampling all the other certification materials that were out there, I felt compelled to do this and to do this for free. So give me that hashtag AWS Solutions Architect Associate. When I start seeing these things pop in, we will begin. I'm starting to see them pop in. Great. All right. So now let's start our boot camp. The first thing we really want to talk about here is the AWS cloud and how it's organized. So when it comes to the AWS cloud, we really can talk about something called regions, availability zones, local zones, and edge locations. So first thing I will talk about is regions and availability zones. We'll take all the mystery out of it for you. So here you can see in this graphic, we have the AWS cloud. You can see this large box in the center view, that blue box. That's a region. That is a huge area of geography. Think a continent, think a country, think a part of a country. Like in the US, there's 2 regions. Basically, you can think, or the main 2 regions are, the west side of the US and the east side of the US, but there's 350 million people in the US, so we're a pretty big country. But so you can think of that large geographic area as a region. And all an availability zone is a data center. That's it. It's a data center. So what is a data center? It is a building that's got lots of power, cooling in it, and it's got routers and switches. It's got servers and storage and load balancers and firewalls. And when it comes to cloud computing, what you are doing is you are renting a virtual data center. But the cloud is still powered by the same data centers that organizations have had for the last few decades. It's just they now rent you space in it. So you can think of it as, instead of building a house for yourself, you check into a hotel when you're on vacation, maybe in Santorini, Greece, for example. Beautiful place if you haven't been there, or whatever the case may be. So now you get it. Large geographic area, region, data center, and those regions, availability zones. So the next component we'll talk about with regards to the AWS cloud and how it's organized is a local zone. So let's talk about why we have local zones, and we'll map it out architecturally. If you need to connect where you're at to the cloud, you're either going to do it over, say, a VPN or a private line or a software-defined networking WAN or a SASE WAN. But when you need to go from your systems to the cloud, it's going to be potentially over a large geographic area. So what does that mean? It means latency or your performance struggles when you have to connect to something that's not directly in front of you. It's one of the reasons private clouds perform the best, because it could be 2 to 3 milliseconds of latency or more just to get to the AWS data center where you're at. So if you have a latency sensitive application and you put it in the cloud, you will decrease the performance of that application. So there's really 2 options. One is you can host them yourselves in your data center. And the other option is maybe there's a data center to you that is closer than the cloud provider's availability zones. So that is what a local zone is. It is a data center between you and the cloud provider that's going to be much closer to the users to reduce latency. So you'll opt into a local zone, you'll create a subnet in a local zone, and you'll put your stuff. What do I mean by stuff? It could be your virtual machines, otherwise known as an EC2 instance on AWS. Azure calls them a virtual machine. Google calls them a compute engine instance, but it's the same thing. You put your load balancers in here, for example. And some of these local zones, which are just data centers that are closer to you, will offer, the ability to do more. Elastic load balancers, elastic cache, some databases and more. But the point is, it's putting a data center between you and the actual cloud provider. So what's this look like architecturally? So in this particular example that we have, you can see we've got this large geographic area called a region, And you can see we've got these data centers called availability zones. So what does that mean? We've got this local zone that's closer to you. So it's a data center, just like an availability zone, but going to be more close to you than the other availability zones that are out there. So let's talk about how you could use this. So in this environment, let's say we have a hybrid cloud. And in this hybrid cloud environment, we've got a data center on our campus. This is where our people work. This is the best performance we have. Now, the lowest performance will be over the wide area network to AWS, but we can actually connect to a local zone. So we can host some things in our local data center. We can host some things in the cloud provider's data center that's local to me, otherwise known as a local zone, or we can put it in an AWS availability zone. So that's really what we're talking about. So let's go through these so far. What have we talked about? We've talked about a region as a large geographic area. We talked about an availability zone, and you'll have multiple data centers per region. And then we talked about a local zone, which is a data center between you and the cloud provider's primary availability zones to reduce latency. So what else? We also have to talk about edge locations. So what is an edge location? An edge location is another data center that is where, typically speaking, where internet service providers all make their connections. It's often called a point of presence. So what happens is when we need to use a content delivery network, say on the AWS cloud, and we'll get into depth about what are content delivery networks and how they work, etc. later when it's time to talk about content delivery networks. The AWS content delivery network is at something called an edge location. Azure would call it a point of presence, which is a much better name of it, but they call it an edge location. So in every major city, for the most part in the world, there's about 217 of them. At least at the time we wrote this content, AWS has an edge location. And in that edge location, what they have is a bunch of servers that actually cache your website information, and they have their own private backbone, which gets your network traffic off of the internet. So I'll show you what this looks like in a minute. So here's an example where we've got our systems that are sitting inside of an availability zone at AWS. And our website is both static contents being served from object storage, otherwise known as S3. Our EC2 instances or virtual machine are serving dynamic content. And we've got users at edge locations. So let me explain the way these edge locations work. Right now, let's say we have a user. Let's say this user is in Athens, Greece. My family's from a village pretty close to Athens, so let's say Athens, Greece. And the user wants to go to www.gocloudcareers.com. So, and we'll get into much more depth of this when we talk about content delivery networks and CloudFront. So the user will enter that www.gocloudcareers.com on their browser. Their DNS servers will give them the IP address or addresses to our website, and then their web request will be sent. Now, if it's the first time this day and the cache is empty, what will happen is the user's traffic will hit the edge location. The edge location will then send it to a regional cache, and if it's not stored in the regional cache, it'll be sent to the web information. And then what will happen is the website will respond. The website will respond. The information will be cached at the edge location, and then the user's information is sent to them. Now, let's say that first person his name was Spiro that decided to hit the edge location. Now in Athens, we have another person. His name is Aguilo. And now Aguilo wants to go to www.gocloudcareers.com. So Aguilo actually hits his local content delivery network in Athens, and the content delivery network says, I have the information. I'm going to give it to Aguilo, and I send it right back to you. And the content delivery network responds and pops it there. So that's why we have these edge locations sitting all over the world for the cloud providers. They're there to cache your web information, to take the load off of the environment. So large geographic area, region. Data center in a region or data centers in a region, they're availability zones. Local zone is a data center between you and the cloud provider to make it to reduce your latency and enhance your performance. And edge locations are internet point of presences to go out there and get your information. So I'll tie these three together. I just walked through the edge locations with you. So here you got an environment. It's me. When I was living in Palm Beach, let's say before I moved to this wonderful place called Port St. Lucie. Let's say that was my on-premise location. And the data center that I would connect to at AWS would be US East, which is over in Ohio, which is not local. So I might actually connect myself to, say, a local zone. If I didn't want to house the information in my data center, you can see the local zone would be, say, in Miami. So from Palm Beach to Miami, it's 100 miles. I don't have any kind of latency worth talking about. I can pop my systems in there. And then I can still backhaul my information to the AWS cloud, which is in the 2 availability zones that I might be using, which could be 1,000+ miles away, because that way we get the best performance from our local zones, and we can still use the capacity and scalability that exists in the standard AWS data center. So I hope that makes sense. Okay, so we will temporarily just do a brief introduction of the VPC, and believe me, we will spend a lot of time on the VPC, because not only are we covering the AWS Solutions Architect Associate in this training, we also have a lot of the AWS security certification in this training and the AWS Advanced Networking in this training, because we wanted to get what you need to be functional out there in the world. We really want to give you as much as we can. So now let's talk about the virtual private cloud. So if you actually can think about it this way, if you think of, cloud computing as basically renting space in someone else's data center, and you can really realize that when you go to the data center, the cloud provider, you get a virtual data center, which is kind of the equivalent of a hotel room inside of a hotel versus a house. So the virtual private data center that you have will be called the virtual private cloud. And basically speaking, the cloud is just a shared environment. There's a whole bunch of users, millions of users that are potentially sitting in the same data center, and they use software to create a virtual data center for you. And in your virtual data centers, where you'll put your you'll put your servers, etc. So that's your virtual private data center. So, but they like to call it the VPC. So now you can look at it this way: the AWS cloud is a shared environment, and you can see how your environment is just a virtual data center inside of the data center. And that's what a VPC is all about. Now, we're briefly going to talk about the types of cloud architectures. And we'll talk about the strengths and weaknesses of each approach. So the first type of cloud architecture that we're going to talk about is, realistically speaking, a hybrid cloud architecture. Actually, before I do that, let's talk about a private cloud. So here's what a private cloud is. We have an organization, and they have their data center. They install cloud software on it, like VMware or Nutanix or IBM OpenStack, and that turns that data center into a cloud. And everything you could do on the public cloud, like AWS or Azure or Google, you could do in the private cloud, whether it be functions as a service or any of the things. It's all the same. The ability to expand and contract servers as you would need, like auto scaling. And in a private cloud, you are going to get the absolute best performance. Why? Because it's your data center, and you can control the network. You control the performance on the network. There's no wide area network latency. It's typically cheaper, by the way, too, the private cloud. The drawback of the private cloud is it's a lot of work to know how to manage a private cloud and design the private cloud. You need experts in networking, experts in security, experts in servers, experts in storage. And what happens in a private cloud is you need to be very focused on making sure your technology is great. And that takes a lot of technical expertise, which requires a lot of highly trained, highly intelligent people and employees, which cost a lot of money. Still, overall, it's generally cheaper to run a private cloud than the public cloud. But, in a private cloud, if you need additional capacity, you don't have it. So you can always scale out to another cloud in a hybrid cloud architecture, or, if your systems are in a public cloud, you almost don't have to worry about it. They're never going to run out of capacity, or for the most part, they never will. So understand that. So private cloud, you make it, you do it, you're under your own route yourself. And many organizations use private clouds. And, many organizations use public cloud. So private cloud is a data center that you run yourself. Now, the next kind of cloud we'll talk about is a hybrid cloud. This is going to be ideal for most customers, and here's the reason why. In the private cloud, we can do any kind of networking we need, so we can create as much network speed as we want. We can make sure that we don't oversubscribe our resources, which is where the cloud provider sells more space and capacity than they actually have, on the basis that not all people use their information at the same time. Kind of like the way an airplane overbooks a flight. Kind of like the way your internet service provider typically sells 10 times more bandwidth than they actually have, because most people don't use it all at the same time. But that's okay. So in a hybrid cloud, you get all the benefits of your data center: almost no latency, the ability to run quality of service and traffic prioritize, the ability to supercharge your security with things like private VLANs because you have control of it, the ability to hire anybody you want to be your security people. And you connect that private cloud to a public cloud like AWS or Azure or Google, or multiple ones. So you put your super high performance compute in your data center, you put all that stuff that runs all the time in your data center, and you put all that stuff that might need a little more agility or scalability in the public cloud. Say a global retailer's website that needs to have auto scaling, say around Christmas, when people tend to buy a lot of gifts, for example, or big sales. So that in the hybrid cloud, data center runs great, plus the public cloud, and then you've got the best of both worlds. Here's what else is good about a hybrid cloud. If a cloud provider goes down, and cloud providers do go down, and you've got your data center, you're up still. So a hybrid cloud could be 50% data center, 50% public cloud, or whatever you want it to be. You can even set up a hybrid cloud where it uses what you've got that you've already paid for in your data center, and when you need additional capacity, it adds that capacity on demand on your cloud provider. So that is a hybrid cloud. The next environment is a pure cloud architecture. Here's what this is. You stick your stuff all in AWS or all in Azure or all in Google. You're inside of that private cloud, and when you're in there, you get some proprietary enhancements, which makes it easier to configure and easier to manage. The downside of this is, generally speaking, none of the clouds are going to be the best at everything, and you limit yourself to whatever that cloud provider has. If you use the proprietary enhancements, you get locked into that vendor, meaning if it doesn't work for you, it's hard to get out. And when that cloud provider goes down, and they all go down, it's just a matter of when, your systems are completely down. So that is a single cloud, a pure cloud architecture. 98% of organizations wouldn't do this because it's too dangerous, because all you need is your cloud provider to have a network outage, a security hacking event, or a control plane, and all the systems go down. And imagine you're a hospital and the tech goes down and people could die. Or your air traffic control and you're on a single cloud and they have an outage, the cloud goes down, and all of a sudden the planes have nothing to guide them. So pure clouds are there, but 98% of organizations are going to go to the next option, which is really a hybrid multi-cloud. And this is what 98% of organizations use. It is where they have some form of a data center and they connect to 2 or more clouds. And that way they can put their high performance things local. They can put their scalability needs in the cloud. And maybe, for example, the Google Cloud's better at some big data thing. Maybe Microsoft's better at AI. Maybe AWS is better in infrastructure. And I'm making that up pure academic terms. I'm not going to take a position on who's better, who's worse, because in tech, it doesn't matter. You choose the best application for your client's need. There is no such thing as the best technology. So I hope that makes sense. But in this case, the hybrid multi-cloud is pretty much what everybody's using. So at least now you know this. Don't ever think that it's going to look just like you would actually imagine. And this is what a lot of organizations are going to have. They're going to have their data center, and they're probably going to connect to 2 data centers inside of a cloud provider like AWS. So they are your major types of cloud architecture. So actually, you know what? I'm going to pause there and take some questions. We'll take questions for a few minutes, and then we will go back to the content. I want to make sure that all of you actually get it, you're learning, and you caught up with, because I know what it's like. You take a course and you lose something, you get lost along the way, and then everything builds on it. So is everybody with me so far? Do you all have any questions? Local zone is just a data center near you. That's exactly it. Everything we're talking about, an edge location is a data center. A local zone is a data center. An availability zone is a data center. But Arun, see, here's the thing when it comes to data centers. You can build your data center to provide high-speed networking like an internet service provider would. Alternatively, you could build your data center to do high-performance GPU computing if that's what you really wanted to do. You could build your data center to put caching servers out there, for example, like you would with an edge location or an Azure point of presence. But all in all, just a data center where you get to put your things near you. And because they're near you, you don't have as much latency. Good question. Chris, we can go to the next one. CloudFront is an edge location? No. CloudFront is a content delivery network, which is a web caching type environment to both protect you an organization from the distributed denial of service attacks and promote scalability of their website by responding to frequently accessed information. We will spend maybe half of a day or a day just on CloudFront. So we will get back to that in depth. But the edge location is where the CloudFront servers are hosted. Like CloudFront itself is a combination of servers and a network. And why would an organization use a content delivery network? Well, internet bandwidth can't be guaranteed. So if you stick your traffic on the internet, there's no guarantees that it gets to its destination. But if you can hit a caching server that has some of the content close to you, and then you could ride back on the private content delivery network to the source, you can get better performance in many, many ways. Chris, let's go to the next one. And while we're at it, before we get to the next question, I should remind you, we've got over 40 lab videos that I'd love you to sign up for. My team will pop a link for that in the description. Additionally, we've got a certification guide, which are the certifications that can help you in your career, especially if you want to be a cloud architect or AWS solutions architect, for example. And if you're having a good time, hit that like button. Chris, let's go to the next question. Is a content delivery network AWS CloudFront? No, we will spend a good afternoon on content delivery network. So a content delivery network is a network of caching servers. AWS calls theirs CloudFront. Akamai has a content delivery network. Cloudflare has a content delivery network. Fastly has a content delivery network. And we'll walk through NS lookup so you can see. And you'll even see that a cloud provider like AWS will use like Amazon will use multiple content delivery networks, because a single content delivery network is a single point of failure. But it's going to take hours to go over content delivery networks. I can't do it in the chat box right now. But when the time comes, we will go over it. So just for right now, remember the edge location is where CloudFront is. Are local zones managed by the cloud providers? Yes, it's their data center. So it's just another data center that the cloud provider owns that, remember, it's close to you. Because the further I go, the more latency I have, the reduced performance I have. We can go to the next one, Chris. What's the difference between a local zone and an edge location? In practicality, not a whole lot, because they're the same kind of data centers. In reality, the edge location is where the content delivery network is. So it's going to have, typically speaking, many more internet service provider points of presence and higher speed networking. And a local zone is another data center, but that data center is designed to be close to you, and it's designed to have more compute and storage, for example, than an edge location, which would be more of a network-based, network-based data center. Do you have to pay for content delivery network services? Absolutely. And they may reduce costs in some ways. And here's the reason. If you don't have a content delivery network, you may need many times more storage and much more transfer of your data. So sometimes content delivery networks will actually reduce your cost if people are accessing frequently accessed information. And we're going to have lots of fun talking about caching and content delivery networks. I can promise you that. So if companies are using a hybrid multi-cloud, that means you should all learn the cloud providers, AWS, Azure, and Google. Well, yeah, Jazz, here's the thing. Yes, you have no choice, but here's the thing, and it depends on your job. See, if you're a cloud architect, you're never going to configure the systems anyway. You're going to design the system, present them, and sell them. And guess what? Here's the good news. We're going to cover this in a multi-cloud way. And if you understand that a virtual machine is what a virtual machine is, then on AWS, you'll understand EC2 instances. On Oracle, you will understand a virtual machine. On Azure, they call it an Azure virtual machine. On Google, you'll understand a compute engine instance. When it comes to storage, if you understand block storage, you will understand an Azure managed disk or an AWS EBS VM, or whether it's in your private cloud, it won't matter to you. If you understand object storage, whether it's Dell EMC's object storage, whether it's AWS S3, Google's cloud storage, or Microsoft Azure's blog, it's the same thing. So it's like you could learn how to drive a Toyota and not know how to drive any other car, or you could learn how to drive a car. When we cover this, we're going to cover it from a actual cloud provider perspective. So you will know that if we talk about a technology, we will tell you the equivalent technology in most cases through this course that you could use on any other cloud provider. Because if you only know one cloud, you're not going to have the skills for any job in today's world, with 98% of organizations using more than one cloud. Are AWS local zones just a CDN? No, Tommy. AWS local zones are a data center closer to you. Why do you have a data center closer to you? Because it's going to reduce the latency for you going to the actual cloud provider's availability zones, which could be 1,000 miles away or more. Are local zones for caching purposes? No, local zones are your data center that you have low latency. Edge locations are used for caching purposes, but also internet presence, point of peering, and a private network. So it's never going to just be servers. In fact, if I can get this across to you, if you don't understand networking, you won't understand how any of these things works. And here's the good news. We have a completely free, and my team will provide you the link, AWS Advanced Networking course taught by 4 network architects, 3 of which are CCIE certified. The other one was CCNP certified. Obviously, lots of them passed the AWS exam as well. And that's free on our YouTube channel. But we'll get into some networking along the way as well. Where do the VPCs have to be? The VPCs are your virtual private data center. So in your own data center, you don't call it a VPC. It's just called your data center. In AWS, it'll be in their data center, otherwise known as an availability zone. So most of what we're going to cover that we have to, but what normal people cover in a certification is the name of a service. We're actually going to tell you what the tech is. And that way, even if you have to go through this videos twice, if you understand the tech, you'll know where to use the tech and you'll be able to understand how to work with multiple clouds. So good question. What's the difference between a cache and DAX? So there is this DynamoDB cache, which is a proprietary cache for DynamoDB. Now, Matthew, I hate to say this, but in reality, you're probably not going to be able to use DynamoDB in almost any environment because 98% of organizations are multi-cloud, which means MongoDB or Apache Cassandra would be what you would use in multiple clouds, as opposed to a Google Cloud Bigtable, DynamoDB, or anything. That's proprietary and honestly doesn't belong in most architectures. And we'll talk about when and where later when you could use it. So that is a proprietary cache for a proprietary database. A cache is basically something that stores frequently accessed information. So there's lots of caches, Matthew. There'll be a cache on your CPU. You may use a cache in a database. So let's talk about what a cache does, and then I'll get back to the content. We'll draw a cache. I'll draw a cache for you. Let me go back to my slides. So here's the way a cache works. And this is going to work in any environment. So let's say this is a server. And it can be anything. This could be a database. This could be a web page. And we'll talk about that. Now, let's say you have a cache in front of it. And this could be a cache for a content delivery network, a reverse proxy. We'll be using caches all over the place, and we'll go through various caches throughout this presentation. And let's say here's your user. So let's say my cat Cindy wants to go look at this tuna picture on the website. And what'll initially happen is, let's change the user to Cindy. User 1 will be Cindy. So here we have user 1, Cindy the cat. She wants to go see tuna. She got told by her buddies on Twitter or Instagram or whatever it was that there's a beautiful tuna that you need to see. So Cindy the cat goes to her computer, types on her pause to go to to go to the website hosting tuna.jpg. The first time Cindy goes to the cache, and the cache doesn't have tuna.jpg. So now the server responds and sends the file tuna.jpg to user one Cindy. Now there's this user 2 that also wants to access that same thing. Now user 2, her name is Sunny the cat. And now Sunny decides to go look at that same photo. So Sunny goes to the cache. The cache says, I have the photo of tuna.jpg. And then the cache actually responds back. And because the cache responds back, user 2, Sunny, got the photo. Now, what was so special? The first time when the user got there, they tried to get the tuna.jpg from the cache. The cache didn't have it, so that was called the cache miss. The second time, the information was stored in the cache, and when user 2 Sunny sent the request for tuna.jpg, it hit the cache responded. So because the cache responded, the web server or whatever it is hosting that image didn't have to respond the second time. So kind of keep that in the back of your mind. That is that's what the cache does. And there's lots of cache, content delivery networks cache. DynamoDB has their own proprietary cache with databases, which we'll really use in an industrial environment. We may want to use a memcached or a Redis cache. So there's lots of caches we could use. And admittedly, we are starting with the more networking, more architecture things. So some of these initial concepts are going to be harder than a lot of the things coming in later. And the last question I'll get to is, why will there be DynamoDB questions on the exam? We have to understand what the exam is. These exams that the cloud providers have are designed to get you comfortable and excited about their services. And they make much more money if you use their service than if you went to a MongoDB. So in a certification course, they're going to try, all cloud providers, every tech provider is going to try to get you super excited to use their stuff. Which is why, as an actual architect, you need to be able to know when to use the cloud providers things and when not to. Now, with every service we go over through, we will give you the information of this will probably work really well in any environment versus this is something you need to know for the exam, but please understand in the real world, if you're an architect, you probably can't use it for these reasons and when you could potentially use them. So I hope that actually answers your question with that. So we only answered most of the questions, and here's the reason why. We have about 10 minutes of questions that we can do each time, and most of the questions that were asked, we're actually going to cover. We just haven't covered it yet. So I love that you're here. I love that you're retaining this information. I love that you're asking questions because that means you're thinking. And if we didn't go over it, we will. And guess what? We'll have lots of time. So we're going to have lots of fun with this. So now we're going to talk about connecting to the cloud. And this is honestly a pretty important thing that most people don't actually understand. If you're going to put your systems on the cloud, you have to be able to reach them, right? So normally speaking, we've got a data center, which is often attached to the building. And if you've got your data center, which is a room full of servers and air conditioner powers and power and backup generators, and storage area networks and load balancers and firewalls, routers and switches, etc. If that's all in your building, you don't need a connection to it because it's already there and you've got your fiber optic cables. But when you want to connect your New York data center, for example, to your employees that are in, say, Miami, because now you need a wide area network. And as organizations, network architects have been designing these wide area networks for years. No big deal. Now, if your systems are on the cloud and not in your data center, you're going to have to reach them. And realistically speaking, I want everybody to know there's two ways you can reach information. Way one is you get a wire between you and your provider. And basically every option we talk about, these are iPhone headphones, but if you get a private line, like a direct connection, which we'll talk about, it's going to be a wire. And, there's other types of wires or virtual wire connections that we can create. But the wire is basically a wire between you and the cloud provider. Option one. Option 2 is we can create an encrypted tunnel between your data center and the cloud and use private addressing. Super secure, just like the first option. And the other option is we use other types of secure VPNs like software-defined WAN or SASE. But here's the big thing. We can also reach things over the internet. So when you go on the internet, like when you reach a website, that's going through the internet. And why am I talking about this? Well, the internet is a dangerous place. Organizations are not going to put their mission critical systems and have them reachable by the internet because they'll be hacked within an hour. They can't do that. So for an organization to reach its private internal information, it needs a connection. And that's what we're going to talk about next. So we don't go through the internet to reach our systems in most cases. What we actually do is go through a private network to access our private system. So when you hear the term intranet, that means systems that are inside that organization's network. When you hear internet, it means the scary internet with everybody and every hacker in the entire world sitting there. So keep that in the back of your mind. So we are going to have to connect to the cloud with a private network of some kind. Otherwise, we won't be able to reach our systems on the cloud. So I hope that makes sense. So what are the ways we can actually connect to the cloud provider? The cheapest way is what's called a VPN. Here's what a VPN is. We take a public network, which is not going to be secure, and we create a private something through that public network. So if you ever hear about MPLS VPNs, it's a type of VPN. When you actually use a VLAN when connecting to the cloud provider on direct connection, which we'll talk about, that is technically a virtual private network. But typically when we talk about VPNs, we're talking about IPsec tunnels. So when we talk about this today, we'll talk about IPsec tunnels. So if you were to send information directly over the internet, you've got a couple of problems. The first thing is the internet is not secure unless you use encryption. So understand that. The next thing that you need to understand is if you're going to participate in routing over the internet, you need to have people that really understand the BGP routing protocol and some pretty big bad routers, because the internet routing table is like 900,000 routes and you're going to get it from multiple internet service providers. And internet routing is pretty darn complex. So unless you have a staff of Cisco certified internet experts, and not even most of them understand big internet routing, that puts it to the pool of that many of us that actually work there. I used to design internet service providers network, so it's my background, but kind of keep that in the back of your mind. Now, if you're going to send your information over the internet, unless you put it in some form of a VPN, you're going to need to have public addresses on everything, because private addresses can't communicate through the internet. But we don't have enough IP addresses for everybody to get a public address, at least with IPv4. And even though IPv6 is out there, it's been out there for 20 years, it's very slow to be adopted. Now, if you're going to connect your information, not only do you need, on both ends of the connection, you need to be on the same subnet. Ugh. How do we do that? Generally speaking, you can't, because one internet service provider and another internet service provider are going to be on separate address space, so they can't be on the same subnet either. So what we do is we create a VPN tunnel through the internet, and after that, we send our traffic. So let's look at what it really looks like. So let's say in this particular environment, we've got a data center in one part of the world and another part of the world. And actually, it could be anything. But let's say I've got a data center, say, in Palm Beach. Nice place, real good weather, warm places. And let's say we want to connect another data center to, let's say, Katy, Texas. We got our team member Alonzo out there. So it's a data center in Katy, Texas. So what can ultimately happen is the data center in Katy, Texas, were to connect to the internet. The data center in Palm Beach connects to the internet, and an encrypted tunnel is placed through the internet between Palm Beach and Katy, Texas. And that means, this router over here, if it wanted to be, to this router over here, can participate in OSPF routing. They could be peers, and they can pass private information through the internet, and it's encrypted. And here's what IPsec encryption gives us. Let's say this router is named Mike, just for argument's sake, and this router over here is named Alonzo for argument's sake. When I use an encryption protocol like IPsec, Mike can confirm that Alonzo is who he claims to be. Alonzo can confirm that Mike is who he claims to be. And that prevents something called the man-in-the-middle attack that you may have heard of in cybersecurity. IPsec also uses a hashing algorithm, and we talk much more about this in the AWS Advanced Networking course, which is completely free on our YouTube channel. My team will provide the link. But there's a hash that basically says the message hasn't changed. So if I send something to Alonzo, Alonzo knows that I actually did send it to him, that it was in fact me, and the data hasn't changed. Why does this matter? Let's say a physician is trying to prescribe a drug, and they prescribe a drug as 2 milligrams, and someone changes it to 200 milligrams. Someone could die. So we need to make sure the message hasn't changed. And IPsec also provides something called non-repudiation, which means that if I say something to Alonzo, I can't go back later and say, I never said that. So that's where IPsec VPNs are. You connect to the internet on both sides, and they're there. But if you look at that, what's the weakness here? We'll talk. The weakness here is, the internet's not guaranteed. So if I get a hurricane, my traffic's not going to get through. If Alonzo has a brownout because they don't have enough power where he lives, and this happens all the time, guess what? He's not going to be there. If there's any congestion anywhere on the internet the entire time, our performance is going to be there. So VPNs are great because it's cheap. Internet access is everywhere. And we can set up an IPsec tunnel in a matter of minutes. Whereas if we have to buy a private connection, that could take a little while. So keep that in the back of your mind. Very easy to create, can be set up in minutes, but VPNs have no performance guarantees. And connecting to a cloud provider with a VPN is typically cheaper if you don't send a lot of data. But if you send a lot of data, it's going to be cheaper to use a private line or a direct connection, which will give you much, much, much better performance anyway. So if we're going to connect to AWS via a VPN, it's going to be, or connect two data centers to each other via a VPN. It's going to be called a site-to-site VPN. Now, in an environment, we can also create a multi-site VPN. And what would that be? Basically, let's say we took Palm Beach, Florida as a hub location. We could have a VPN to, say, Montego Bay, Jamaica, really beautiful place over there. We can have another one to the Cayman Islands, and Florida could be the hub in between them. That would be considered a multi-site VPN. Now, when you connect a VPN, you have to terminate the VPN on something. You just can't connect to something. It has to be terminated somewhere. So normally it's done by a VPN concentrator. With the cloud provider, they basically have a gateway that you connect to. It'll be a VPN gateway. And when you create an AWS VPN, IPsec VPN, or pretty much any VPN for the most part, what'll happen is you'll set these things up. They will go through an internet key exchange, which are the security keys that are going to be used for encryption and decryption. They will determine the type of security attributes for the tunnel, maybe the algorithm they use for the same encryption, the encryption type. And then you can typically set up your routing, which could be BGP or whatever it would be. In a private environment, you might use an interior gateway protocol like OSPF, for example. But when it connects to external organizations, you have to use an exterior gateway protocol like BGP. So we'll use BGP for this. So I understand. Now, one of the things I want you to understand is when you connect to AWS, they call it a high availability VPN. And I want to show you why they call it that. But I want to show you the practicality of why it's not going to be high availability enough for you. So let's say this is your data center, or this is your campus, or this is wherever you're at. I'll call it campus. Let's say this is where your employees are. And here's what AWS does, which is honestly incredibly cool if you understand what they're doing. So you've got two availability zones. Let's say you're using two availability zones in a cloud provider, two data centers. Not enough for a super high availability, but good enough for most organizations. You're going to have this VPN gateway, this VPN type device, whatever it's called. And what AWS does, and this is very cool, and this is why they call it a high availability VPN, is this virtual VPN concentrator will automatically create a virtual private network to the two different availability zones, which means, and this is very cool, if you have a connection from your router to this virtual, this virtual VPN concentrator, and this link goes down, you still have another connection to another availability zone. And I will tell you right now that this virtual device won't crash. As long as the cloud's up, it'll stay up. It's a logical link, not a physical router. Here's why this isn't good enough. Because if the link between your organization or your campus and the AWS virtual router goes down, you have nothing because there's no wire between you and them. And if this router were to die, guess what? If the router goes and the link's up, well, the link will go down because the router's not there. You still have no connection if the router's dead. So if you really want to design these with a high availability wide area network, what's going to need to happen is this. The organizations are going to need to have 2 routers, and they'll have to be across different wide area network providers, and they will connect to 2 different virtual gateways. They will have, and this could be done over a physical wire or a VPN, it doesn't matter, across different internet service providers. They will have these 2 virtual routers and 2 links, and that way either router at the campus could go, or either link could go, and you're still up and able to connect to your systems on the cloud. I hope that made sense. But this is why these things are so important to think about from an architecture perspective as these systems would be designed. Now, pretty much what goes into setting up a VPN is very simple. You make sure your systems are connected to the internet. You're going to determine which AWS virtual gateway you're going to connect to. And you'll pick a routing method where you put static routes or dynamic routing via BGP. And that's it. It's pretty much set up. Okay, so let's talk about the next kind of wide area network we can use. And this is what businesses do when it matters. So if you're going to put your systems on the cloud and you need real performance to get it to them, you're not going to leave your performance open to whatever the windfalls of the internet are. And honestly, all it takes is a pop star to send a tweet of their cat, and if this pop star has 50 million followers, poof, next thing you realize the internet can be congested. So when it matters, organizations use private lines. So a private line or a private wide area network connection, we guarantee your bandwidth. If you buy 10 gigabit per second, you know what you get? 10 gigabit. If it's 2 milliseconds across your link, it's going to be 2 milliseconds. It's not going to be like the internet where it's 5 milliseconds, 10 milliseconds, 7 milliseconds, 80 milliseconds, that variation. And certain applications like video and voice tend not to do well with variations and latency, otherwise known as jitter. Private lines more reliable. It is guaranteed. And you can take multiple private lines and bundle them together. And you can create something called the link aggregation group. And that way you can lose some of the links and still be up and bundle the performance. So let's really talk about what goes into it, and then I'll architecturally show you what it looks like. When you connect to a cloud provider or a wide area network provider and you're using a private line, if it's going to be Ethernet, it's going to be fiber optic. Now, if it's a short distance that you're connecting, say switch to switch, you can use something called multi-mode fiber. But when it is a long distance, you have to use single mode fiber. Because the cloud provider is a long distance from you, or the direct connection location that you'll be connecting to, when you use a fiber optic connection, you will need to use single mode fiber. So, going to be a test question right here. So, what specifications would you probably use for your direct connection? If it's gigabit Ethernet, it will be single mode fiber and it will be 1000 base -LX. So I'll just say it again. You may see it in a test. For a gigabit Ethernet connection over direct connection, it will be single mode fiber, 1000 base -LX. Now, and that's pretty much a standard protocol. Now, if you want a 10 gig connection to the cloud provider, you are going to be using 10G base -LR. And keep that in the back of your mind. And if you've ever worked with fiber optic connections, you know there's 2 labels. There's a send label, a laser, and a receive laser. And in your routing protocol, it's possible that one of the sender receives goes down and the other link is still up. So it could potentially take, 60 seconds, 90 seconds, or minutes or more to detect that you can't really communicate over that link because it's really dead because it only goes one way, not the other way. And if you know anything about TCP, for example, it requires, bilateral communication. So you lose one side of it, it goes down. AWS supports bilateral forwarding detection, that just like every other technology vendor does, and that gives you the ability to detect a downlink, which is great. When you send something to a cloud provider, you're going to be sending it over a shared connection, which means you're going to be dealing with something called a VLAN and an 802.1q tag. And we're starting with the harder stuff, the networking thing, so it's going to get easier as we go along. But if you don't know networking and you don't understand the networking, everything falls apart. So that's where we're going to start here. So it'll be backhauled. So let me kind of show you what this would look like real quickly. So this is what it's typically going to look like. You'll buy a connection to a co-location facility. And that's going to be called the direct connection location. And this box over here, right over here, where it says customer or partner space, that's the wide area network link you buy. You'll notice that AWS, where it says AWS space, has a network that goes right back to AWS, the AWS Global Network on the side of this. So what has to happen is you will basically need to take a wire that's going to connect your customer space and connect it to the AWS space. And this is something called the cross connect, where you're going to connect in a meet-me room and you'll basically have a switch or a VLAN. So it's the way it works. You connect to the direct connection location center. AWS is connected to the direct location center, and your cable needs to be run between your device and their device. That's called a cross connect, and that is the way this works. So there's some things that we're going to need to talk about when we go through these direct connections. So I just showed you that you've got the cloud provider stuff and you've got your stuff. Now, they can't just let anybody buy a connection into the building and then connect that network port of yours to AWS. Because what if you were bad? What if you were a hacker? What if you just tried to sneak in there and connect into the systems? So you can't let somebody plug into your systems without knowing who they are. It's called physical security. And they need to be a permitted user of the system. So in this particular case, you're going to need to get permission from AWS to go from your stuff to their stuff to get that cross connect. So what'll happen is you will go to AWS and you will ask for a letter of authorization. And basically you can request that letter of authorization either from the management console, there'll be a place to do it, an API call, or the command line interface. You will request that letter from AWS. If your application is approved, and it will be because they want to connect you, they will provision the switch port that you connect to at the direct connection location center, and they will allow those two cable to work. You'll download the letter, you'll give it to the service provider in the direct connection location, and they'll run that cable or the cross connect, which is just a cable between you and them. Now, when you connect to AWS, you're going to have two different links that you can connect to. You're going to connect to a private link, and you're going to connect to also, you have the option for public connections. So let me explain to you what I kind of mean like that. And then I'll explain them in depth. Bear with me a second. Take my little drawing board over here. We'll draw this out. Sometimes, working through it with a whiteboard, to me, is the easiest way to learn these things. So you've got let's do this. You've got your direct connection location. So this is your location, router. This is your router or switch at the direct connection locations facility. Over here is going to be the AWS router or switch. So this is yours. I'm going to call it customer owned, customer edge. Now this is going to be another router, and this is going to be the AWS. It's going to be considered the private edge. And then AWS has some stuff that's public and has some private. So this is your VPC. And then let's say, and your VPC is private, right? Oops. You want to make sure it's private anyway. And then AWS will also have some public services. Oops. So what'll ultimately happen is you will buy this link between you and the provider. You'll get your letter of authorization, and that will enable that cross connect between you and the AWS router. And then you can use a public interface, and they can build you basically a virtual tunnel to things, say like AWS S3 or object storage. And you'll have another tunnel that'll be your own private network that's going to go back to your VPC. So I kind of think this will make sense to you. So now that you see that, let's talk about AWS and public and private interfaces. So a public virtual interface enables you to connect to all AWS public services in your region that you have the direct connection to. So what's that mean? DynamoDB, something like SQS, and any kind of public endpoint. And if you're going to do that, because it's public, the cloud provider is going to have to use a public IP address to be reachable from the public, and your address will have to be public because it's basically going to have to be routable, a globally routable address. And the way you'll reach this is by exchanging BGP with AWS. So that's something public. Now, a private interface is going to be the exact opposite. A private interface, or a private virtual interface, is going to be a tunnel to the resources in your VPC, just like a Valtia. And you'll advertise your routing information from AWS, but they only accept a very minimal number of routes. So you're going to need a good IP addressing plan, and your network architects are going to have to aggregate or summarize your routes to make it work. So let's talk about some more things so far. So a direct connection gateway. What is a direct connection gateway? A direct connection gateway is going to be an AWS service that enables you to connect your AWS infrastructure to your data center using a private link. The benefit of using that direct connection gateway is that it enables you to connect to more than one VPC, or for example. So you connect to the direct connection gateway, and that enables you to connect to various things. So you can view the direct connection gateway as a router with virtual links, just like we've been using in the data center for the last 30 to 40 years. So how does this work? A direct connection is you basically will get your direct connection and connect it to the direct connection gateway through an AWS delivery partner. Now, how many of them are there? There's about 60 of them in the US. Companies like AT&T, Comcast, Sprint, British Telecom. And, the partners will usually be based upon your region. And delivery partners will have their global infrastructure, and they'll terminate their networks inside of an AWS co-location facility. And that way you can connect to AWS. Now, when you connect to AWS, it is not going to be over a private wire. It's a private wire to you, but it's backhauled to AWS. So if you see this, and I want to go back to this, you are connected via a private wire to this. This is your stuff. And then you'll get a cross connect, which effectively is going to create a wire between you and AWS. You see it as a cross connect on those switches, but it's going to be at a layer 2 thing, so you won't see it. And then you see that this little black lines that go back to AWS. This could be you and 10,000 other customers that are going to AWS on that same link. So how do you keep your information private? You're going to have to do something on the network side to send that information to them. And what's going to happen is you're going to be sending them a VLAN. So what does that mean? So the way it's going to look is going to be something similar to this. So we're going to draw more switches here. I think it'll make it easier. So let's say on the switch, it's not going to work. Let me get rid of this fill. Bear with me for a second. I think this will help. Okay, so let's just say this is a port. So what a VLAN is a switch can have multiple ports. Oh wait, I have one. Hold, this will make it easier. So here's Here's an enterprise grade switch, and you can see it's got multiple ports on it. And you can see these all right now out of the box. Every one of these switches, ports in the switch can talk to each other. But what if security purposes you wanted only these ports to talk to each other, and then only these ports to talk to each other, and only these ports? You would create a VLAN. So going back to my example here and how this is going to work, here we've got a bunch of switch ports sitting in a switch. I'm going to double these intentionally. The top, we'll call it VLAN 1, and anything in VLAN 1 can talk to VLAN 1. Oops, don't want to get that 2 in there. And then over here, we've got anything in VLAN 2 can talk to VLAN 2. So we're going to connect to their switch at the direct connection location. And they're going to have a whole lot of ports and a whole lot of VLANs. So what's going to happen is they'll basically make a VLAN for you to connect to. Actually, I think it'll be easier if I draw it this way. What I'm trying to do is just take about 500 to 1,000 hours of networking and condense it to about 5 minutes here. So what'll happen is when you place something on the wire, you see how this one says 1? This is going to be a frame that would leave the switch. When it leaves the switch, it's going to stick a tag on it. And in this case, we're going to put let's find a color for this. We'll put a yellow tag on it. And when the frame is pushed on the wire, the switch will pop this tag on it. And when the switch reaches its end destination, it'll take the tag off, and it'll pop this back into a VLAN 1 on the switch. And that's called the trunk port. So when you connect to AWS, or the switch connects back to AWS, imagine they've got thousands of these VLANs sitting here. And the way they keep your traffic off segregated is they pop a tag. Now, maybe VLAN 1 has a yellow tag, and maybe VLAN 2 has, oops, let me pop a tag. And maybe VLAN 2 is going to have a different color tag, because every VLAN has to be unique. And that's how it works. So VLAN 1 hits the wire. And when it reaches the far end switch, this is stripped off, and this goes back into VLAN 1. VLAN 2 hits the wire. They continue as a unit till they get to the end. When it gets to the end, this little tag gets stripped off. VLAN 2 is placed in VLAN 2. So I kind of hope that works. I tried to oversimplify a lot of networking in a short period of time, but so keep that in the back of your mind. Now, we can also do a couple of other cool things. When we use these direct connections, we're going to have to exchange routing information. What is routing information? It's how to reach your subnets. And we've got a good video on subnetting that my team can provide a link for. And we've got a good 8-hour video that me and Mark Milovanovic, 2 CCIEs, made for you on BGP. Can't cover it here, but my team can pop that in the chat box. Recommend you watch it. It'll help you a lot in your career. So now let's talk about these private virtual interfaces a little more. Remember, those private virtual interfaces go to your VPC. And the AWS Direct Connection Gateway, which we talked about, is a router for you to connect to, which enables you to connect to, say, different resources. Just keep that in the back of your mind. Now, when we're actually sending our information over a direct connection, we can also encrypt it as well. And here's what I mean by this. We can run IPsec over a direct connection, or we can encrypt at layer 2 using something called MACsec. And if you want to learn more about MACsec, you can just look at the IEEE specification 802.1AE. And for some more information about that, that's what I would do. So let's talk about our direct connection virtual interfaces. I talked about the private virtual interface and what we use it for to go back to our systems. I talked about the public virtual interface, and that's how to reach, to example, how to reach AWS public services such as DynamoDB. But I didn't talk about a transit virtual interface. And a transit virtual interface enables you to take your direct connection on-premises environment and connect it to something called a transit gateway. And AWS has transit gateways, which are basically routers that you can also connect to. And here's an example of what this could look like. You can basically take your data center, you connect to your direct connection location center, and you connect to your VPCs via these private connections on the left. You can connect to transit via this transit VIF, and that's going to connect you to transit gateways, which can take you to, say, other VPCs or other environments. And you can use a public one, which you don't really see here, to connect to some AWS services, for example. So let's talk about why you might want to use a direct connection gateway. Well, if you need to connect to multiple, say, environments to your VPCs, you could run multiple connections. And if you run multiple connections, you've got multiple connections, which means multiple direct connections to pay for. So that's one thing. If I have 4 10-gig connections and each one's connecting me to something different, I've got 10 gigs to access service 1, 10 gigs to access service 2, 10 gigs to access service 3, and 10 gigs to access service 4. Now, or I could, and that we bought 4 private lines and we've got 40 gigs. By comparison, if I've got one 10-gig connection and I split it with the direct connection gateway, the max bandwidth I can get is 10 gigs, and I can share it to those other 4 things. So I could potentially get 10 gigs if those other virtual links aren't doing anything, or I can get a maximum of 10 gigs. So, keep that in the back of your mind. A direct connection gateway will reduce the number of links that you need, so it will reduce your costs. But it will also reduce your performance, so it's based on what you actually need. So if you connect via a direct connection gateway, you're going to get reliable, low latency performance. And that's going to be a whole heck of a lot better than you would get over, say, an IPsec VPN over the internet. And it's going to give you some security because it's a private connection, which is more private than the internet. And you can now encrypt that too, and it gets really good, really fast. So I hope that helps. I covered a lot of networking. I won't be able to answer all the questions on networking, but I'll do the ones that we can, and most of the ones we'll actually cover as we go through this program. But let's take some questions for a few minutes, Chris. And before we do, I want to remind you, we've got over 40 labs, real good labs for you to do in your spare time. You can get them in the description of this video or the chat box. We also have a certification ebook that we wrote for you, the kind of certifications, if your goal is to, say, be a solutions architect or a cloud architect, the certifications that will build your brand and make people more inclined to hire you versus the certifications which may scatter your brand, scatter your efforts, and will keep you getting hard because it'll make somebody not see you as where you really want to be seen. What's the difference between a direct connection gateway and a NAT gateway? A direct connection gateway is a router that I use to create a private link between you and the cloud provider. And NAT gateway takes your private addresses and converts it into a public address for them to go out on the internet, much like a firewall does. So you may be at work, and if you do an ipconfig/all on a Windows machine, ipconfig/all, you'll see that you may be coming from a 10.something.0 address base, a 172.16 address base, or maybe a 192.168.1/0 address base. They're all private addresses that can't be routable on the internet. So a NAT gateway will take your private address, translate it into a public address, so you can go out to the internet and your traffic can come back. But they're totally unrelated to what we're talking about. But we will get into NAT and NAT gateways. Direct connection gateway gets you to the cloud. Is message digest the same as a message signature? Not really. So message digest, something like message digest 5, is a type of hash. So and we don't typically use this type of hash anyway for this reason, and I'll talk about why. So message digest is something that can be hacked in a matter of minutes with a modern GPU. But what's the point? So with a hash, here's what happens, and we can't get into all the math in this course, but because it's PhD level math, it's really cool stuff. But here's what you need to know: when you put something into a hash, it always comes out. A consistent input comes out. So if I put a letter A in, and I have a 256-bit hashing algorithm like SHA-256, the letter A will come out as 256 characters of something. Every time the letter A goes into the hash machine, the same output comes out. So why do I do this? Because I can guarantee if I put a message in, you can guarantee that the message hasn't been changed by comparing the hash. What's super cool about these one-way hashes like MD5, even though MD5 is outdated, is so if A comes out as 256 characters of numbers, you can't go from those 256 characters to figure out that it was really the A. So imagine being able to put a banana in something and have it come out as a Mercedes. But you couldn't take the Mercedes and turn it back into a banana because you wouldn't even know that it was a banana in the first place. So that's the hashing that's typically done in IPsec to make sure that the message hasn't changed. And so imagine somebody puts $1 billion in their bank account. They're real rich. And somehow someone changes the $1 billion to $1 and siphoned off the other $999,999,000. They wouldn't be too happy. So that's why we use hashes to make sure the messages haven't changed. Does a local zone have a VPC or just an AZ? So local zones have VPCs. And here's the thing. If you remember that the VPC is nothing more than a virtual private data center that sits in a data center. So a local zone is a data center near you. An availability zone is the main data centers that's far away. So yes, you can definitely have your VPCs. You can create subnets in that VPCs that's specifically going to be associated with your local zone, the same way that you would create subnets in an availability zone. Really great question. And Prab, as you like to go by, I'm so happy to see you here today. Look forward to seeing you soon in class 2. Okay, wow, that's pretty great. So I guess we will get back to the content. I'm giving you the rough content first, so it's going to get easier and more fun as we go along. So I figure we all start with lots of energy. So I want to know that you're awake, alert, and oriented. I come from internal medicine, and we always are obsessed with checking that. So I'd like to know that you're still here and awake. Give me a hashtag, please, AWS Solutions Architect Associate. Hashtag AWS Solutions Architect Associate as one word. And that will really help you there. And that way I can know that you are awake. And also, if you're enjoying the video, please give it a like. Please subscribe to the channel. Hit the bell to be notified of new videos. And check out the descriptions of our videos. There's a lot of free resources in all of them. Free guides on your career, free guides on how to pass interviews. Lots of descriptions of our videos have these things. So please go get them. Is a direct connection the same as a VPN? Well, yes and no. In practicality, the direct connection is technically a layer 2 VPN, but not really. So a VPN that normally we think about is an IPsec tunnel, where a direct connection is kind of like buying a wire between you and the end location. You own the wire, you've got guaranteed bandwidth, guaranteed performance, guaranteed everything. So they're not really the same. Good question, though. All right. So now let's talk about link aggregation groups, something I always love talking about. So what is a link aggregation group? So if you need high-speed access, you're going to need to use a direct connection. And sometimes you can't get enough performance in a direct connection. So what if you need more than one connection? If you do 2 separate connections, now we've got to do some cool BGP magic. And I'm okay with that. I love BGP, but it adds to the complexity. If we do more than 2 if we have 2 wires in a layer 2 environment, one wire will be natively blocked by spanning tree. So we can't use both of them. But if we can bundle multiple little wires into a big wire, that's what a link aggregation group is. So in order to make this work, we're going to have to have 1, 2, 3, or 4 identical links. That means same speed. So if I've got a 10 gigabit link, I can't have a 10 gigabit and a 1 gigabit link. They all have to be 10. They also have to be the same latency, which means if AT&T's link is 2 milliseconds of latency and Verizon's link is 3 milliseconds of latency, or vice versa, I can't bundle a Verizon link with an AT&T link. I'm going to need to put all these links together, same speed and latency, which usually means same provider. So in networking, we have a saying, in high availability architecture, we have a saying that says 2 is 1 and 1 is none. One cloud considered reckless by many organizations because it's a single point of failure. When organizations buy a wide area network to AWS, they're not going to buy 2 links from AT&T and hope that the AT&T network doesn't have a catastrophic outage. They will buy 1 link on AT&T and maybe 1 link on Verizon or NTT or CenturyLink or somebody else. So with the link aggregation group, if we need to bundle 4 links from, say, AT&T, chances are we're going to need to bundle a backup 4 links with, say, a Verizon. Keep that in the back of your mind. So by default, a AWS link aggregation group will stay up if any of the connections in the bundle fails. So that's default. What if you have 4 links on this link and 4 links with the backup, and 2 of the links fail on AWS, on, say, AT&T, but all 4 of your links are in Verizon? Wouldn't it be better to send your traffic over Verizon, which has double the bandwidth than AT&T? Well, you'll need to deal with that, to traffic engineer that, to make that happen. Because by changing, and there's some tuning things that you can do on your link aggregation group, like the minimum number of connections for the link aggregation group to stay up. So what does this really look like? Let's go whiteboard it out. I'll show you what a link aggregation actually looks like, and then I'll show you what it would need to look like if we needed to do high availability. So let's say we've got an Ethernet switch over here, and we've got another Ethernet switch over here. So let's say this, I'll make it on the fatter side for a line. I'm going to say this is 10 gigs. So instead of leaving that as 10 gigs, I'll have another one which gives me 20, another one which gives me 30, and another one which gives me 40. That will look to the routers and switches as a single 40 gig link. Let me try to make this more transparent. And that means, you don't have to deal. So what it'll see, it's going to see this as one big link, as 40 gigs. And that's totally fine. But if all these links have to be the same performance, that means they're going to have to, for the most part, be all on the same wide area network provider. That wide area network provider becomes a single point of failure. So what you'll ultimately do is, if it really matters and you need this kind of bandwidth and you're setting these link aggregation groups up, and this is the kind of client I work with, you're typically going to have one link aggregation group, which is, say, 4 10 gig links on one ISP, and then you're going to have another 4 gigs, 4 10 gig links on another ISP, and that way you've got ISP failovers. So kind of hope that makes sense. So that's what we're really talking about with regards to link aggregation groups. Now let's do a basic networking review, basic stuff. So this is something you all really need to understand. It's something called the OSI model. And this OSI model really is a standard way for people to describe technology. And the reason we must do this, we have to, is that if I speak to you in Greek and say "Πώς είσαι σήμερα," and you're speaking to me in another language, say English, if you don't speak Greek, we're not going to understand. Now, one of the reasons I never use acronyms in real life, and one of the reasons that is they cause errors. So the networking people were very smart. They said, look, if we're going to talk about the network, we have to all describe it the same way. We can't have a virtual machine, which AWS decides to call EC2, and Google calls it a compute engine instance, and Azure calls it an Azure VM. We have to have a standard name. Well, when it comes to networking, we need standard names. So we talk about the 7-layer OSI model, and let's talk about what it is. At the physical layer, that is our wire. That is physical. So I got a fiber optic cable between two switches. We send photons on that fiber optic connection over via a laser or pieces of light. It's there. If we are on what do you call it, a copper cable, like an Ethernet cable, standard Ethernet cable, we're sending electrons. We're going to call it bits that we're actually sending over it, but that's the way these cables work. So layer 1 is the physical layer. Layer 2 is the is the hardware level, the card. So every device has a physical address. Well, the wire itself doesn't have an address. It's just cabling. So layer 2 is the data link layer. So if you think of the Ethernet card sitting in your notebook, that Ethernet card is a hardware card that connects you to the network. That is the data link layer, otherwise known as layer 2. Now, guess what? Your card actually has a hard-coded address. It's called a MAC address. So if you're in a Windows system and you do ipconfig//all, you'll see the physical address called your MAC address. You will also see something called, so you will see the MAC address. You will also see the next level up, which is the IP address of your system. So layer 1 is literally mean a wire. Layer 2 is actually the data link layer, or frames that we're sending, or MAC addresses. Layer 3 is the logical addressing. So the IP address. Before everybody used IP, we had Apple Talk addresses and CLNS addresses and IPX addresses. So layer 1 wire, layer 2 card, layer 3 network. And at the network, we send packets. At layer 2, we send frames. At layer 1, we send bits. At the next layer is how we send the data. So do I send the data reliably using TCP? Am I sending a ping or a test message, which is Internet Control Message Protocol? Am I sending real-time streaming data via the RTP protocol over UDP or UDP? So that's layer 4. Now, for the most part, networking is layer 1 through layer 4. So when you deal with a network engineer like me, or someone that used to be a network engineer before being a network architect, everything we dealt with was, is it cabled layer 1? Are the Ethernet ports plugged in, or are the ATM or frame relay devices plugged in and hard-coded with the right, link layer address? Do the devices have the right IP addresses at layer 3? And is it TCP traffic or UDP traffic or ICMP traffic? So that's really all networking people think about. But we're going to go up. We also have to control the connection between the two devices, and that's done via a session layer protocol. And at the session layer, we talk about sockets. Now, we may be dealing with encryption, such as TLS encryption, which was the replacement for the old SSL. Encryption is done at layer 6, or the presentation layer. And the application layer is what you use. Open up Google Chrome, that's at the application layer. Your TLS encryption was a connecting between you and, say, a website. When you see that little lock and it's HTTP-S, it's done at the presentation layer. The session layer controls the connection. The transport layer is that TCP, UDP, ICMP kind of thing. The network layer is your IP address. The data link layer is the MAC address in your system. And the Ethernet cable you have is the physical layer. Oops, didn't mean to do that. I have some. So let's talk about giving an IP address to your VPC, IP addresses in your VPC. So if a device needs to be reachable, it has to have an address. If I want to send a mail to somebody and I put it in a letter, I need to know their name, their street address, their street number, their postal code, the state or country they're in, that kind of thing. Otherwise, how will the mail person know how to deliver the mail? Well, same thing in networking. You connect to something via its address, and every address that's going to be talking to everybody else needs to have a unique address. Now, even your mail has to be unique. You could have everything. It could be on 123 Main Street. And but the zip codes are going to be different, or the postal codes. So keep that in the back of your mind. When it comes to IP addressing, there's two forms. We have the form which is reality for now, which is for the most part IP version 4. And we have the future version that's been the future version for 20 years called IP version 6, which is predominantly used at today's point for putting IP addresses on mobile phones. But hopefully at some point it'll be used, because we kind of challenged with IP addressing for V4. So when you provide IP addresses for your VPC, it's internal to your data center. So what kind of IP addresses do corporations use inside of their data centers? Private addresses, meaning the addresses that were specified to be private. So if you want to learn about the private addresses and where they're at, you can go to the IETF.org, the Internet Engineering Task Force, and look up RFC 1918. That's the actual specification for private addresses. And that's what we network architects look at. That's what people read when they have actual specifications, when they do like a Cisco certified internet network exam. And my number is 7417 when I passed that exam 20 some years ago. So the addresses that are specified here are going to be the 10.0.0.0/8, the 172.16.0.0 all the way to 172.31.0.0/16, and the 192.168.0.0/16 address space. Remember, these are private addresses and they are not globally routable. In today's world, everything we're going to be using is classless IP addresses. We don't deal with classful addresses anymore. But for argument's sake, the 1.0.0.0 all the way to the 126.255.255.255/8, that was a Class A address. In case you were to see that on an exam, it's not reality for real. There's classless interdomain routing, but now you know. For Class B addresses, it begins with the 128.0.0.0, and it ends at the 191.255.255.255. And they're all /16s. We have the Class C addresses, which are the 192.0.0.0 all the way to 223.255.255/20, all /24s. And of course, the IP multicast addresses, which were the Class D addresses, which are 224.0.0.0 all the way to 239.255.255.255. So that's academic. That's why we covered it. That's why I went over it quickly. So in today's world, we use classless IP addressing, which means subnetting and supernetting. So Mark and I did a 6 or 7 hour or some really long subnetting workshop. We had a couple of Cisco certified internet experts doing it for you because we wanted you to get it for real. So we did that. My team will drop a link to that in the chat box so you can see that. So you'll be given a CIDR block, which is the whole range of IP addresses, and you'll have to chop it down and subnetting this down. So why do we use subnetting? I mean, what's the point? Well, the point is that every router needs to be on every interface on a router needs to be on a different subnet. For the most part, every Ethernet card in a server needs to be in a subnet. And I could use 4 ports with the /8s and literally burn up and waste 16 million IP addresses and never be able to use them again. Or I can have 4 ports in a router and subnet them to /30s, and you lose 16 addresses versus 16 million addresses. So you get the point. It's about efficiency. That's why we're subnetting. So what? And in that video, that subnetting webinar that my team talked about, they will teach you how to subnet. We spent hours and hours and hours doing it. There's also a BGP workshop you should see. But in practicality, what is it really that we're doing? It's really this. Let's say I gave you the CIDR range of 192.168.1.0/24. You could chop that into multiple smaller subnets. Say, for example, the 192.168.1.0/28. And then you could consider maybe a 192.168.1.16/28. And then the next subnet you could use would be 192.168.1.32/28. The next subnet you could use would be 192.168.1.48/28. The next one you would use would be 192.168.1.64/28. And that's really what we're talking about. And you can see I took a network and subnetted it down. to show you /28. So if I only gave you that single /24 subnet, which only really could support a total of 256 hosts, or -2, so 254, you can see I've taken that block and I've subnetted it down into quite a few different subnets. And this is how we efficiently use IP addresses. We use the right kinds of subnets, and we do classless internet domain routing. Now, and again, we covered it in that subnetting workshop. I can't cover it here. When you send routes to AWS or any cloud providers, they're limited to like 100 or 1,000. So you can only send them a small number of routes. Now, I'm going to tell you, a modern enterprise has 5,000 routes in the routing table. And a cloud provider is like, well, we can take 100 from you or something small like that. So if the IP addresses are designed properly, you can basically summarize them. And I'll show you what we did here. And by summarizing them, it reduces the memory and the CPU utilization on your routers. And what does this look like? Well, it looks like this. Like if we only had 100 routes that we could share with a cloud provider over BGP, and we had these /24 subnets, these 4 of them, we could send 4 of these. But what happens when we've got 14,000 of these? But we could take these 4 and summarize it into a single route. So depending upon how we summarize the routes, we can limit how much information the cloud provider needs to know, or another provider, which can give us traffic engineering. But that is way outside of the scope of a solutions architect associate. We're talking, network architect, CCIE level things for that. So please watch the video, and that'll at least get you there. But that's why we have to do these things. Now, lastly, I'll briefly introduce the concept of an IPv6 address. So an IPv4 address is a 32-bit address. So what does that mean? It means the total addresses I have are 2 to the 32nd power minus 2. So there's that. And that's because each bit is either 0 or 1, on or off. So people that design IPv4 and others kind of realize, the internet, what they designed it was, a private research, military university kind of thing. There weren't a lot of users on it. No one expected everybody to start using the internet. Every house to have 2 and 3 computers for the most part in many parts of the world. People to have IP phones that have IP addresses on it. Refrigerators which text message you while you're at the supermarket telling you what you need to buy. Your TV that's pulling Netflix and Amazon stuff, and maybe some houses have multiple TVs, etc. So no one really realized that the internet was going to grow behind the few billion addresses that it initially had. No one. So if a 32-bit binary address, which was 2 to the 32nd power minus 2, wasn't enough addresses, they needed to fix it. So instead of a 32-bit address of 0 and 1, they came up with a 128-bit address that was in hexadecimal address space. So binary is 0 or 1. Hexadecimal is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. A alpha, B Bravo, C Charlie, D Delta, E Echo, and F Foxtrot. So now we have 16 to the 128th power. Now you can see we've got lots of addresses for all these wacky weather sensors that are out there, car sensors, self-driving cars, IP-enabled drones, mobile phones, you name it, and it's there. So that's kind of where we're coming from. I think there's even toaster ovens that'll actually talk to you. So there's that. So now we're going to get into the VPC. And here is where we're going to get into a lot of the geeky stuff. After this, it gets real easy. So seatbelt in, muscle up, and we'll get you there, all of you. So the components of your virtual private data center, which they like to call virtual private cloud, is going to be your routing to the internet via an internet gateway, different types of ways to kind of NAT your information out to the internet and come back, which will be NAT instances, NAT gateways, etc. We're dealing with public IP addresses. We'll be dealing with things called endpoints. We'll be dealing with how do you connect multiple VPCs to each other. We'll talk about some packet filters, otherwise known as access control lists, like you'd use on a router, but AWS calls them network access control lists. And we'll talk about like the host-based firewall that comes with AWS services called a security group. So we'll begin with, the routers have a routing table in them. And in order to go to your destination, every device in the world, what it does is it sets up a routing table. And what's a routing table really? A routing table is just a list of destinations. So if I've got a router with 4 links, to reach the 192.168.1.0 subnet, go out this link. To reach the 192.168.2.0 subnet, reach this link. To reach the 172.16 subnet, go out this link. To reach the 10.1.2.34, go out this link. And that's why the routers build a routing table, is they build a map. So if you're going to be able to send traffic around your cloud, you have to know how to get your traffic from point A to point B. And this is why we need virtual routers. So that's, realistically speaking, what we're actually talking about is the virtual router and the virtual router itself. So the routers will need this map. So what's this map going to look like? You're going to see a routing table, and it's going to look like this. It's going to say the 172.16.1.0 subnet is local to me. But to reach the 192.168.0.0/16 subnet, use that PCX-123456 link. But to reach this one critical subnet, which is more specific, even though it's inside of that aggregated route, 192.168.1.0, go out the left link, please. PCX-654321. And then you'll see something called the 0.0.0.0/0. That is a route that basically says, if you don't know where to go here. And that's going to go to the internet gateway, and it'll say like IGX 123456 or whatever that number is. That's the map. So how do you build the map? Well, you have to build it somehow. So there's going to be a couple options you could use. Option 1. Let's say you got a network which has got 5,000 routers. You manually go to all 5,000 routers and you configure them with 15 lines, 15 statements as to reach this, go this way, to reach this, go this way, to reach this. So now you're going to have somebody SSHing into a router and litting and cutting and pasting, thousands of lines of routes to 15,000 devices, for example. And as soon as one link gets cut, you're now, not only will the traffic not know how to heal itself, but you're going to manually have to go to all 15,000 routers, and you're going to manually have to reconfigure them. And when that link comes back up, you're going to have to go back and do it again. So clearly, static routing doesn't work very well or doesn't scale. So what is a static route like? For any of you that are old enough to remember you wanted to go visit your friend's house, so you looked at a paper map, and you said drive 3.5 miles and then make a right on 123 Mulberry Street, then drive on Mulberry Street for 2 miles and make a left onto Main Street, and you printed yourself a list of directions. That's a static route. Then on the way to your friend's house, there was a roadblock because of construction or a car accident or something, and you didn't know where to go. That's static routes. In today's world, we have these little things called GPSs. They're on our phones, or they could be in our cars, depending upon the cars we have. And now you're on the way to your friend's house, the road is blocked, and you make a right, and it says recalculating route. Please make a legal U-turn here, go here, and then you get to your destination. Well, I get lost when I drive my car. It's pretty bad, so the GPS is my friend. I also love routing, and I spent most of my life designing routing. So something I like. So when it comes inside of organizations will use what's called an interior gateway protocol. And inside of an organization, we're going to use things that are designed and optimized for speed. Now, when we connect to organizations outside of our organizations, we're going to connect to them via something called an exterior gateway protocol. Now, here's an example of basically the way a cloud provider would be laid out, or the way a data center or an business's data center would be laid out. You can see that inside to their organization, they're going to have a bunch of routers and switches, and they're going to run a routing protocol like OSPF or ISIS, or potentially EIGRP, but that's proprietary, so we don't really use much of it in today's world. And then when they connect to another organization, they connect to each other via BGP. Why BGP? We use BGP because it gives us what we call a lot of nerd knobs and enables us to tune and configure and traffic engineer our traffic. It gives us control over the routes we take in and the routes we come out. So when you connect to an external organization, they'll be in a different autonomous system than you, and you'll use BGP. When you connect to the cloud provider, they are not you. So you use BGP. When I connect to 3 different internet service providers and share routes, you use BGP. But the cloud provider is different to you. And how do you know they're different? If you note, every organization will have something called an autonomous system number. In this example, I used private ones, but you'll have your autonomous system number. The cloud provider will have theirs, and you'll connect to them via BGP. That's how you will do dynamic routing. So AWS, like all cloud providers, will allow you to use BGP because it's the only exterior gateway protocol we have. Test questions to remember. BGP uses TCP, the Transmission Control Protocol, port 179. I'll say it again. BGP uses TCP port 179. Why did I say that twice? First, I wanted you to know it's a TCP-based connection-oriented protocol. And if you have a firewall between you and the other person, and you don't allow or open TCP port 179, BGP will not be able to establish a peering relationship over that link, and you won't be able to reach anything. So please understand that. So if you use a direct connection, and if it matters, you're going to use a direct connection when you connect to AWS, you will need to use BGP. If you use a VPN, you probably should use BGP, but you don't have to. You could do static routes. Now, AWS supports this BGP community called no export. Here's what no export is. If I were to tell Chris something and I tag my routes with the community no export, Chris couldn't tell Alonzo, who's my chief marketing officer, something. So that's no export. If I didn't have the community no export and I connected to Chris via eBGP and sent him a message, and he connected to Alonzo via eBGP and sent him a message, Alonzo would get the information that I sent him. So AWS enables you to use that community to not become what's something called the transit autonomous system. AWS BGP implementation, the BGP implementation will enable you to traffic engineer traffic, meaning you can manipulate the weight, the local preference, the AS path, the specificity of the routing information. Now, understand it's a very light BGP implementation, but you're going to have to dress wisely and see somewhere routes. Mark Milovanovic and me produced an 8-hour BGP training session. It's completely free on our YouTube channel. I'll make sure my team drops that in the link for that. So here's BGP has this concept of transitive and non-transitive routing. So here's transitive routing. I've got my data center. Chow, who's a wonderful cloud architect that works with us, has her data center, and Alonzo has his data center. In transitive routing, I tell Chow how to reach my stuff. Alonzo tells Chow how to reach her stuff. Chow tells me and Alonzo how to reach her and each other. And that means Alonzo can talk to me because he knows how to reach me. Alonzo will see in his routing table his route, which is the 192.168, 1.0/24, Chow's 172.116.0.0/16, and my 10/8. So in transitive routing, Alonzo can reach me. If I wanted non-transitive routing, which we happen to have in VPC Peering, which we'll get to soon, or we would have in, say, iBGP, here's what would happen. I would tell Chow about my routes, and she would tell me hers. Alonzo would tell me, would tell Chow about his, and Chow would tell Alonzo about hers, but I wouldn't be told anything about Alonzo from Chow because it's non-transitive. Say we have the BGP community now export. That means I can reach Chow and Chow can reach me. It means that Chow can reach Alonzo and Alonzo can reach Chow. But in non-transitive routing, I can't reach Alonzo because I don't know about him, and Alonzo can't reach me because he doesn't know the routes either. So I hope that makes sense. And we'll get to much more depth on that with BGP peering. Actually, Chris, I think here's a good time to pause, take some questions, and then we'll go back to the content. What is meant by one wire being blocked with spanning tree? Maybe explain what spanning tree is in the context of link aggregation group. So FB, if you'd like to learn about spanning tree, there is an IEEE specification on spanning tree. And we also have a completely free CCNA program. So I can't get too deep into spanning tree right now because it would take many hours, but I'm going to walk you through and show you why we need spanning tree. And I think this will help. So we're going to do a little architectural drawing over here, and I'll show you why for switches they must use a protocol called spanning tree, and why if we have routed links we don't have to worry about this. So here's the way a switch works. The way a switch will work is, let's say I've got a destination. Hold on. Put up. I may have a frame that comes into the switch, and let's say its MAC address is 12:34:. That's not going to work. Well, I know how we'll do this. Let's say I have an Ethernet frame and its destination MAC address is 12:56:67:89:01. So let's say I've got a MAC address. What a switch does is this MAC address comes into the switch. The switch sends it out every single port except the one it came in on. And then when the packet gets to this switch, it'll send it out all ports on that switch except the one it came in on. So I've got one frame here. I've got one link. Here's what happens. Let's say this switch has 100 ports and it goes out this link. It gets sent out 100 ports. And if there's no problem, everything works. So if you just got here and you haven't seen what an Ethernet switch is, it looks something like this. So packet comes in on, say, one of these ports, and it goes out every port in the VLAN except the one it came in on. I hope that makes sense so far. So if I've got one link, I've got no problem. Now, at layer 2, if I have two active links, I want you to understand what's going to occur. Let's say the frame starts here. Frame hits this switch. It goes out this port. Now, this switch will send it out every single port on it, send it out every port except the one it came in on. So it's going to now send it back to this switch. Now, when the frame gets back to this switch will send it out every single port except the one it came in on and send it back on this switch. And this switch will send it out on every port except the one it came in on. And what ultimately happens is the switches will have all this broadcast traffic, because every time there's an ARP that gets broadcasted out or all unknown traffic, and then all these links will be filled. So when it comes to link traffic in Cisco, and did I not share that? Apologies, I've been meaning to share this. So let's walk through this situation again. I have a single link that's up and working. So sorry. So frame comes into the switch. It sends it out to the next switch. The next switch sends it out all ports except the one it came in on, and it dies. I'm going to do that again. Single link. Single link hits the switch. It goes out all ports except the one it came in on, at least till the switch is nowhere to send it. And then it goes out all ports on the switch. Life's good, right? We've got one link. Now, I've got two active links. Here's the problem. Frame comes into the switch. The switch sends it out all ports except the one it came in on. So the switch sends it out all ports. So it's going to send it out this port and this port if nothing were to be blocked. Now, when this frame comes in on this link, it's going to go out this way. And then that switch is going to send it out all ports except for the one I came in on. So it's going to loop, and it's going to loop, and it's going to loop, and it's going to loop. And switches do this with all unknown traffic or broadcast traffic. So a host sends an ARP who has this MAC address, gets sent out. So what will ultimately happen in switching is this traffic will just loop and loop and loop and loop until it fills up, literally speaking, all the links. And then the thing falls down. It's called a broadcast arm. So what spanning tree does is it blocks one link, because if it comes in here, it can't go back, and we don't have that broadcast storm. So, plus it drives the CPUs like crazy because they have to process all the broadcasts. So it fixes it. Now, if you've got two links and you can't use the link because it has to be blocked, so you prevent a broadcast storm, you only have one active link. What a link aggregation group does is they bundle all these links so they all look like a single link, so that to the switches between them, it's only a single link. So now, frame comes in, unknown, goes out this one port, switch sends it all our ports, and it doesn't go back. That's why we can create a link aggregation group, and we don't need to mess around with spanning tree, because it's one wire versus two wires. I hope that made sense. That is a pretty complicated topic, so we covered it fairly heavily, and when we did the CCNA. So please go back to that if you'd like more. And my team prompted that there for free. It's free training we did. What is a session cookie, and how is that related to the browsing experience? Well, it has honestly nothing to do with what we're talking about now. But by definition, a session cookie is typically going to be a temporary cookie that's going to be put in your browser, and it's going to stay there until you close your browser. The point of using a session cookie is to keep track of what you've done on, say, a website. Maybe keeping you logged in, keeping the things that are inside of your shopping cart there. So when I go to PetSmart to buy Bonkers cat treats, because these little tuna lollipops that my cat likes, I start to order them, and then my wife says, please cook me dinner, and I cook my wife dinner, and I go back to my browser and it's still there. That's typically why you would use a session cookie. It's there to kind of provide a better, more seamless and personalized browsing experience. So it enables websites to remember key information during the session. Good question there, but not really AWS content, but that's all right. Chris, we can go to the next one. Well, Miguel, so GBP, do you mean the Great British Pound, or do you mean BGP, the routing protocol? So I'm going to work on the assumption that you're using BGP versus a VPN. A VPN is a private connection inside of a public environment, so an IPsec tunnel through the internet. BGP is a routing protocol, which is how the routers calculate how to send your traffic to the best destination. And that's how you connect to external entities. So if you have a VPN, that's just going to create a virtual wire over the internet for you. But the routers won't know how to send your traffic from point A to point B without a fully populated routing table. So you'll either have to manually go assign the routes to every single device, or you'll use a dynamic routing protocol. And when it comes to connecting to the cloud providers, it must be BGP. And you had said BGP. Good. So I did a good guess there. All right. Well, we'll get back to the content then if there are no more. And I'll fill my water here because you get dry talking for lots of hours. And then we'll get back to the content. But before we do, I want to make sure that you get all the stuff that we have to offer in this session completely free. Please check out the description of these videos because there's lots of freebies for you that are going to help you. But there's over 40 labs that we've done. And we want you to go follow through with these on your own time. And if you sign up for the labs, then the week after the session, we do some free personal AWS mentoring. And you want to be part of that, you'll be notified just by signing up for the free labs. So get the free labs, work them on your own time. We're going to go 3 hours per day for 10 days. That's 30 hours. So we need to get very deep and more deep in the tech content, which is what I'm concerned about. So go get that. We also have a completely free certification guide for you. And again, it's completely free. And it'll talk about maybe the certifications you'd want to be a cloud architect or a solutions architect. Because most people get the wrong certifications and it actually hurts them more than it helps them. It keeps them learning all the skills other than the career they actually want. and it makes the resume look like they're a combination of a physician, airplane pilot, lawyer, police officer, dog walker, as opposed to being out there looking like you've got the perfect skills and you've focused your training and efforts and you've got lots of depth. So we've got that for you. And again, it's completely free. So they're in the description of this training session. My team has popped it in the video. Please go out there and get the BTP on our YouTube channel. Please go out there. And, we do this free and we do it periodically because I interviewed 1,000 AWS certified people and I asked them basic questions, and sadly they knew how to configure it but not answer things. And people hire you for your knowledge of what is the system, how does it work, why to use it. So we do this free. I know most people can't afford live training, so we do it free and love doing it. So if you're having a good time, please give it a like. Please subscribe, hit the bell to be notified, and please share with friends. Share the wealth of this knowledge. There's lots of jobs out there, despite what you've heard. And when you've got the right skills, the world's your oyster. So please share this free training with many others. And then I'm going to start as soon as I see some hashtags. So give me a hashtag AWS Solutions Architect Associate. We'll get back to the content. And my team even put the free AWS Advanced Networking Bootcamp. And the free CCNA Bootcamp, you've got 2 to give you some extra networking knowledge. All right. So as soon as I see some of those hashtag AWS Solutions Architect Associates, I know you're here. I saw the first one come in from an associate of mine. Thanks so much, Preb. Really happy that you're here, along with all of you that are here. All right. So now we're going to talk about internet gateways. Well, I want to make it really simple for you to understand. Do you know what a gateway is? It's another name for a router. Your default gateway is where you go when you don't have a route. Hope that helps. An internet gateway is a router that connects to the internet. So in AWS, you connect to virtual routers versus physical routers, but it's the same thing. So when you want to get your systems reachable from the internet, like your web servers, or perhaps a VPN concentrator, for example, that's when you need an internet gateway. Now, when you connect to the internet with an internet gateway, it's going to connect you to the internet. So what does that mean? It means your systems are reachable on the internet, which means if you do not have a well-designed demilitarized zone, they will be hacked. And it means that only stuff that you want to be reachable from the internet should be. Maybe a VPN concentrator, maybe a web server, but all that private stuff should not be there. So different subnets, route filters, firewalls, etc. You're going to need all of it. So, beyond that, the way you're going to make this work is you'll attach an internet gateway to your VPC. That's our internet router. You'll create a default route, which says if you don't know where to go, send your traffic to the internet gateway. You'll put a public IP address on the gateway, and then your systems will be reachable. Now, if any of you do, and if you actually take your computer and you type netstat, let's not go there, but you'll be able to see that your PC, if you do an IP config /all, or you IP configs /all in Windows, or IF config on, say, a Mac or a Linux system or a Unix system, you'll be able to see your IP address and your default gateway. It's the same thing we're talking about here, nothing different. So, realistically speaking, it's going to look something like this. You've got your stuff. Anything that needs to be reachable will have a public IP address. It'll have a route to the internet gateway, which will go out on the internet. And that's why you can see in your routing table here, you've got your private subnets, which are local. And then you've got your, I don't know where to go, 0.0.0.0/route, which means send to the default gateway, which is the internet gateway. So that's all an internet gateway is, a router that connects to the internet. So next, egress only internet gateway. So what does egress only means? It means stuff can go out, but not in. Okay, so why would you use that? Let's say you had systems that needed to go out to the internet and patch themselves. and download, say, the newest patches for Ubuntu or the newest patches for Red Hat, or Linux, etc. But you didn't want them to be reachable from the internet. You'd use some form of an egress-only internet gateway. That's it. That's what all that is. So in IPv6, we don't need NAT. So we've got enough IP addresses. So we don't really have private addresses. It's mostly public addresses. So with IPv6, we can create a gateway which basically says go to the internet and then come back and your stuff is allowed, but you're not reachable from the internet, meaning someone can't go from the internet and come back to you. So if we do that with IPv6, it's called an egress-only internet gateway. And an egress-only internet gateway is basically like being behind a firewall, sort of, being allowed to go out to the internet and come back. Since we're on gateways again, I'm going to talk about a virtual private gateway. And an AWS virtual private gateway, often called the VGW, is going to be an AWS resource that enables you to connect your AWS VPC to your on-premise. So normally speaking, you would connect a VPN concentrator to a VPN concentrator, or a firewall to a VPN concentrator, or a router to a VPN concentrator, or your PC to a VPN concentrator. So the AWS virtual private gateway is an AWS-designed, AWS proprietary VPN concentrator. And that's how you can make your connection. And the connection can honestly be any kind of connection you want to use, but often a VPN. And here's a visual example of how they work. So you might have your corporate data center that's connected over a direct connection gateway. You could have your data center connected to different virtual private interfaces that you could see. You can have another IPsec tunnel that's going to your a VPN that's coming in through the virtual gateway. They can be different IPsec tunnels or what have you. So there's just lots of different ways that it's basically a virtual router to connect you to two different locations. So because a virtual private gateway is like a VPN concentrator, you basically, each VPC can only have one virtual private gateway. So what you do is a virtual gateway will be attached to the VPC, and then you can establish a whole bunch of VPN connections or multiple private lines to the virtual private gateway. And the AWS virtual gateway will establish two types of connections, either a VPN or private line. So we can also create a VPN to another network. So because that virtual gateway is kind of like a VPN concentrator, you can use that to establish VPN connections to maybe your on-premise environment. You can use it to connect to, say, Azure and Google. Remember, 98% of organizations are multi-cloud, so you're going to be using things like this. And it's going to create a VPN connection, which is going to basically use it for a VPN connection, which is usually using an IPsec tunnel. And because you're using an IPsec tunnel, you can put your routing anything you want on either side, and you can determine whether you're going to use BGP or a static route. Static routes aren't going to scale because you're going to be manually configuring stuff, and it's just going to be a nightmare. You'll make more errors, and when a cable gets cut, they won't naturally heal around it, so you don't want that. So here's another example of what it could look like. You could have your region, and you could be in, say, two different data centers, otherwise known as availability zones. You can create multiple VPN connections between different environments, like you see on the right side, connect to the VPN gateway and use that as a router to connect your location. So it's an option for you to use the cloud as a wide area network in certain cases, and allow other organizations to use the cloud as like a hub and spoke environment, and multiple environments can then reach each other through it. So when we're dealing with a private line or a direct connect using it, we're going to connect to the virtual interface called the VIF. And what we'll do is we'll utilize the direct connection virtual interface, and then the virtual gate will provide us a private dedicated network connection from the on-premise to the AWS. Now, that private line using the direct connection virtual interface And this virtual private gateway is going to give you very high performance, guaranteed, because it's a private wire. By comparison, if we were using VPNs, it wouldn't be guaranteed. So remember that the virtual gateway allows you to connect multiple VPCs to your on-premise environment, and many organizations will chop up their organization into multiple virtual private data centers. And why might they do that? So in a normal data center, you can really micro-segment your network. You might take your network and chop it up into mini VLANs. You can't really do that on the cloud. You don't have a lot that you can do. So many organizations will take their organization and chop it into 10, 50, 100 or more virtual private clouds. And then you can connect what you need or don't need via these virtual private gateways. And you've got layer 3 routing and firewalling, things you can do in between them. So kind of hope that makes sense. So now let's talk about NAT instances. So a NAT instance is a virtual machine that does NAT, that translates one address into another address. And you can basically use an internet gateway plus a NAT instance to take your information and send it to the internet and allow it traffic. And a NAT instance is potentially useful in certain circumstances, but in most cases, a NAT instance is something that you're probably not going to use that much anymore. And you're probably going to use a NAT gateway, because a NAT instance also needs an internet gateway. That's extra devices to manage. And a NAT gateway will give you internet access and do network address translation at the same time. So what's really going on here with NAT? If you'll recall, anything on the public internet needs to have a public IP address. But anything in a private network needs a private IP address. So how do you go from the private world to the public world? Well, either you've got your routing right, and every device that you have has a public address, and we don't have enough public addresses for every person in the world and every device in the world. Or you take your private address and you translate it into a public address when you go out to the internet. And there's lots of types of NAT: one-to-one NAT, one-to-many NAT, static NAT, dynamic NAT, or something called NAT overload. And if you're going to be a network architect or a cloud architect and you were in our cloud architect training program, we'd get into that. But that could be 10, 20 hours of stuff just to go through NAT, let alone this rest of the content we need to do. But so let's talk about what a NAT gateway does. It provides a router to the internet, and it connects you to and it does NAT. Takes your private addresses to it. And it's something called NAT overload, often known as port address translation. And why is it NAT overload? I'll show you right now. Well, maybe I can't draw that on here. Oops, I don't even know what happened there. I better not play too many buttons here. So let's say the NAT gateway's external subnet is 1.2.3.4, and you've got 1,000 users in that private subnet. It will translate all 1,000 users into 1.2.3.4, but it will utilize different port numbers. So the address might look something like this. I can maybe draw addresses on another slide to kind of put it into context for you. I'm drawing these slides on dynamically. How do we do this? Okay, so let's do this. So if the external address with NAT overload, we might have a 1.2.3.4 port 2023. And then the next user might be 1.2.3.4 colon 2024. I don't know why that's looking so funny. And what you can see is this colon enables us to use the 1234 with one set of ports and another set of ports. And the port numbers that we're using gives us the ability to create additional addresses or equivalent of addresses. So understand that. So NAT gateway takes you to the internet, allows your traffic to go out to the internet and return traffic to come back, but you're not reachable from the internet. Internet gateway is a router that connects you to the internet. You go out to the internet, your traffic can come back. An egress only internet gateway is a NAT gateway for IPv6. Think that and keep those three. And they're basically the three you'll actually see on your exam. So now, let's talk about the concept of an elastic network interface. An elastic network interface is the equivalent of an Ethernet card sitting in your virtual machines, often called as EC2 instances. By default, when you launch a virtual machine, it's going to have a network card in it, a virtual network card. And the default network interface in any AWS environment is going to be considered ETH0. But if you wanted more than one network card in your system, or because you want to connect to multiple subnets or dual home that host, you just pop another network card in it. Same way you've done in the data center for the last 40, 50 years. Dual home. And there's lots of reasons you would do that. So kind of think of that in the back of your mind. So an elastic network interface is a virtual network card. So now let's talk about elastic IP addresses. So inside of your corporate environment, your VPC, you're going to have private addresses. When you go to the internet, your internet-facing things like your website have to have a public IP address on it. So the load balancer that's going to be front-ending your web servers has to have a public address on the outside of that load balancer, for example. So how do you get them? Well, normally you call your internet service provider and you buy or register a public IP address. And there's other people you can buy blocks of people for IP addresses from, same way you can buy a BGP autonomous system number. But on the cloud, AWS has a pool of public IP addresses. They're called elastic IP addresses. So what happens is when you need a public address, you borrow it from the pool, you pay for it. AWS gives you the public IP address called an elastic IP address. I didn't make up these names. And then after that, when you're done with it, maybe a year later, you shut off your load balancer, you give it back to AWS. So that's it. And if we've got a NAT environment, we can have one public address via NAT overload, otherwise known as port address translation, provided to lots of devices. So keep that in the back of your mind. We also might use an elastic IP, maybe as a secondary address for certain things that we might put on an interface. I hope that makes sense. So an elastic IP address is just a public address you get from AWS. Now, endpoints. All cloud providers have endpoints. So what are they really? You need to connect to something. That's an endpoint. Like if you were going to connect a wire to something, you can't just leave the wire dangling in the air. You need to connect it. So that endpoint is where you connect it. And we're talking about logical things. So we have two ways that we can actually understand things, connect to things. We can go out to the internet, come back, or we could just get a connection between them. Could be a virtual wire, could be a physical wire. So let's talk about what this actually means. If we go to the internet, actually, I have a picture that I drew. Let's talk about this. If I wanted to take my data outside of my environment, I have two ways to do it. I can go out to the internet. Now, I'm going to go out to the internet, and the internet's not a secure place, so I'm going to have to encrypt it or something to make it better. And the internet has no bandwidth guarantees, meaning you could get 100 gigs or nothing based upon whatever the internet has. You can go out the internet, and you could come back to, say, an AWS service, say object storage, otherwise known as S3. You could do that. But you're going from this thing, which is in your VPC, which is on the Amazon network, which is safe and secure, all the way out to the scary, dangerous internet with the security risks and no bandwidth guarantees. And then you're going to come back into the secure AWS. Well, that would be ridiculous. So what you can do is basically AWS can make you a virtual wire called an endpoint, and it's going to connect your VPC, which is your virtual private data center, directly to an AWS thing, all without going to the scary, risky internet. And the internet has no bandwidth guarantees. So you're going to want to use an endpoint to connect to certain AWS services. So we'll talk about the different endpoint options that we actually have. So the point of these endpoints is security, reduced latency, and keeping your information. So let's talk about some endpoint benefits. They enhance security because you're not going out to the scary internet. They enhance your performance because to go from AWS to AWS on their private network is going to be fast because they can guarantee performance of their network, but they can't guarantee the public internet. It's a better performance. Management. Well, it's a lot easier to not be thinking about NAT gateways, internet gateways, going in and out of the internet to access our own stuff. And it's much more secure. And generally speaking, the cloud providers charge you, for traffic that you use, although that's getting a little better on certain cloud providers. So keep that in the back of your mind. So there's going to be two kinds of endpoints we have in AWS. We're going to have gateway endpoints, and we're going to have interface endpoints. Gateway endpoints are typically for, say, Amazon S3, otherwise known as object storage, and the Amazon proprietary NoSQL database called DynamoDB. An interface endpoint, by comparison, is typically used for AWS virtual machines, otherwise known as EC2 instances, AWS Lambda, AWS SNS, AWS Kinesis or Secrets Manager, and many of those things are proprietary, and you really can't use multi-cloud. And we'll talk about them when we go over the multi-cloud, when we go over those services, and we'll also talk about what you can use instead in a multi-cloud environment. So I kind of hope that makes sense. So how do we set up and use an endpoint? We pretty much go to the VPC dashboard in our management console. We select endpoints and we click create endpoint. No big deal. And then we're going to choose the kind of gateway that we need. We'll review, make sure we did it right, and create the endpoint. So it's really no big deal to set this stuff up. It's knowing what you want to set up that's more the challenge. So we'll begin with an interface endpoint. And an AWS interface endpoint is going to be a type of VPC endpoint that's going to allow you to privately connect your VPC to a supported AWS service. Now, when you use an interface endpoint, it uses something called PrivateLINK via AWS PrivateLINK, and it's kind of just like a virtual wire they create for you. Interface endpoints, what they really do is they create a virtual network adapter, otherwise known as an elastic interface between you and whatever you're connecting to. And that way, everything's simple and elegant. Here's an example of what it typically looks like. Maybe you've got a VPC that's got some proprietary service that you want to connect into, and you're using PrivateLINK to connect to it. This could also be an AWS service on, it could be a certain service you want to connect to. I'm sorry, I'm looking at this diagram that my friend drew for me. So, basically you can see inside your VPC, you're connecting to an AWS public service. Thought this was another example that I had drawn for me of using this to connect to something else. So AWS has something, you're using this VPC endpoint, which is basically a network card and a private wire between you and this AWS service. So let's talk about some key features with AWS interface endpoints. Private connectivity. It's going to be private and secure. As I mentioned, it uses these network interfaces, and they'll be in the private IP address spaces. You can secure your interface endpoints with your identity and access management solution, and you can add some VPC security groups to it as well, which is kind of firewall-like. By using interface endpoints, it scales well. And for the most part, it just automatically scales to handle our traffic needs. Because these endpoints are not physical, they're logical. They typically don't go down as long as the cloud provider is up. And it's very simple management because we're not using NAT gateways and translating different addresses, etc., as necessary. So very simple and elegant way to connect to an AWS service. And lots of uses for interface endpoints, EC2, simple notification services, functions as a service like AWS Lambda. SQS, Kinesis, Secrets Managers, many of the databases, systems managers, lots of stuff that you can connect to with PrivateLINK. And that interface endpoint uses AWS PrivateLINK, and that's a networking service that enables you to basically securely access the systems in AWS. Private connectivity between VPCs, AWS services, what have you. So private connectivity, things that you can think about, and again, it's going to be that private network interface card, that elastic network interface on both sides. Data stays on your same thing. It is a logical wire versus a physical wire. So as long as there's connections in the cloud provider, it can give it to you. And pretty helpful. So how do you set up PrivateLINK? Well, you create your VPC endpoint. How do you do that? You go to the management console, you select endpoints and click create endpoint. You choose whatever service you want to connect to. And you configure the endpoint. You give it a service name. You choose the VPC that you want to use to create the endpoint. You select the subnets in your VPC where the endpoint will be placed. You set up a security group to control who can access it. You review it and you create it. So it's no big deal to create these things. And it gives you good secure connectivity across the AWS cloud. So let's talk about some security considerations when we're dealing with PrivateLINK. Use the security group. I mean, why wouldn't you? It's basically a host-based firewall that you can put on an interface endpoint to control access and restrict traffic. Create an IAM policy. So make sure that the people that have the right permissions can access it and nobody else. You don't want to give this access to everybody. Only people that should be accessing things are people that need it for the job. If you've got this kind of endpoint kind of situation going along the way, you probably should do some monitoring and logging. So look at your CloudWatch logs. Make sure you enable VPC flow logs. They're kind of like the equivalent of Cisco NetFlow to kind of see how and where your traffic is going. Set up your private DNS to ensure that DNS is enabled for the VPC to be able to get to resolve the traffic so it gets to the endpoints that it needs. So that was an interface endpoint that we talked about in PrivateLINK. The other type of endpoint to talk about is something called a gateway endpoint. And that's going to be a high-speed access to an AWS service like S3 or DynamoDB. These work a little different. They actually place a route in the routing table. So the routing table will look and say, oh, to go to S3, go that way. Same thing as it would normally say to reach the subnet, go that way. So the way that works is you create an endpoint. It's going to create a prefix list for the endpoint. And the prefix list will look like a route in the routing table. And you'll see it as PL-something, something, something after the fact. And that'll be the route in the routing table for the endpoint. So you're going to use this for secure access for S3 often. And it enables you to set up policies. So you can maybe access, say, an S3 bucket. You can also limit the routing information to subnets that need to know how to reach the endpoint. Because if you don't have a route, you can't reach it. So it's going to further enhance your security. So there's that. Now we'll talk about VPC peering later, but PrivateLINK connect to a very specific service. VPC peering connect multiple VPCs, so totally different. PrivateLINK connect to an AWS service. VPC peering connect to another virtual private data center, either that you own or another company. VPC peering, you can connect a small number of other VPCs. PrivateLINK is connecting to a lot of AWS services, much more scalable. PrivateLINK is unidirectional, so goes in one way. Enables a consumer to connect to the provider. If you need communication to occur in both directions, you need to set up bidirectional communication. So if you use VPC peering to connect two VPCs, they share everything. When it connect to an AWS service, use PrivateLINK. So now is the fun time to talk about VPC peering. I love VPC peering because it's kind of like BGP peering. So what is VPC peering? An organization may have multiple virtual private data centers. And how do you connect two or more data centers? You peer them with BGP, right? And that way you share the information that you want and you get connectivity between them. Well, what if you're a company? Let's say you're a computer manufacturer and you want to connect to the CPU manufacturers, and Intel's got their, what do you call it? Their, what's the word I'm looking for? VPC, and AMD's got their VPC, and you want to connect to Intel for buying Xeon chips for certain servers, and AMD to buy those super fast EPYC processors for your big high superpower servers. So you can connect to both of them. If they're on AWS, you can connect to them. Now, when you connect to an external company, you got all kinds of security things because the other company and you. Or you could have a company like GE, and they could have an aerospace division and a healthcare division and another division, and they could all be hosted on AWS, and they can reach each other through AWS, through the AWS network via VPC peering. So that's what's VPC peering. Or you could be super security conscious and put your finance people in one VPC, your accounting people in another VPC, your sales people in another VPC, your test dev environment in another VPC, and really reduce the blast radius so if something big happens, nothing really happens. So keep that in the back of your mind. So that's what is VPC peering. So here's a visual representation. Someone from my team drew. And in this particular environment, you've got your data center or your virtual private cloud. You're connecting to another virtual private cloud, and you've agreed to share stuff. That's VPC peering. So there's some things to know with regards to VPC peering. VPC peering is not transitive. I showed you an example before as it pertained to BGP, but I'll show you some architectures. All right, so when it comes to VPC peering, either we will have to do something to make hub and spoke work, because hub and spoke won't work by nature because, and I'll show you what hub and spoke environment looks like, because VPC peering is non-transitive, or we need to fully mesh our VPCs. So if anybody's familiar with IBGP and you fully meshed your IBGP peers, that's the reason why. Or with IBGP, there was a workaround to IBGP being not transitive called the route reflector. So we'll talk about that in a minute. So when it comes to fully meshed, and I'll talk about, there's going to be a scalability problem, but I'll show you. So here's what a hub and spoke network is. And in transitive routing, you can see that VPC B, C, D, A, E, F, G, kind of like a song that I've heard recently. But anyway, and in a normal hub and spoke environment, VPC talks to VPC-A, VPC talks to VPC-A, and in normal transitive routing, VPC-B can talk to VPC-C because they're going to be going over from here to here to here. That's allowed. But remember, in IBGP and VPC peering, what will happen is VPC-B will tell its routes to VPC-A, and VPC-A will tell its routes to VPC-B. VPC-C will tell its routes to VPC-A, and VPC-A will tell its routes to VPC-C. But VPC-B will not know about VPC's routes through A because the routing is non-transitive and routes aren't propagated. Likewise, VPC-D won't be able to reach VPC-C through A or B because it's non-transitive routing. So in transitive routing, it works perfectly. In IBGP, we need to do something to this VPC-A to make it be transitive if we want it to be transitive, and that's called a route reflector. And in BGP, we'll have the option to do CloudHub or Transit Gateway. We'll talk about that in a bit as a workaround to this. But normal VPC peering is not there, so we have to fully mesh our VPC peers. What does that mean? It means every VPC is going to need a connection to every other VPC. So pretty simple here, right? VPC-A connects to VPC-C, VPC-C connects to VPC-B, and VPC-B connects to VPC-A. So here's the traffic flow. If VPC-A wants to reach VPC-C, it sends it. VPC-C wants to reach VPC-B, no big deal, it sends it. VPC-C wants to reach VPC-A, they send it because they're all exchanging routes with each other. Here's the problem. When we have three of these, It's no big deal, but here's the formula. N times N minus 1 divided by 2. So in this particular environment, let's run through the math. We have 3 VPCs here, VPC A, B, and C. So we have 3 times 3 minus 1, which is 2. So that gives us 6, right? And we divide that by 2. So we've got 3 connections, which is here. Why does this become a problem? Well, what happens when N becomes 100 and 100 becomes 100? So now let me get my calculator out to show you exactly where the problem becomes. So now with this N times N minus 1 divided by 2, we have 100 times 99 divided by 2, which means for 100 peers, we're going to need 4,950 connections. Whoops. That's not going to work. That's going to be more than ugly. So kind of keep that in the back of your mind. So that is our options. We either fully mesh them or we do something to break the fully mesh rules. In IBGP, it's called the route reflector. We'll talk later about transit gateways and AWS CloudHub, which are ways that you can actually break the rule. So now let's talk about the AWS Client VPN. So let's say you've got lots of employees. Typically speaking, you put up a VPN concentrator and you allow your employees to remote access it, connect your VPN concentrator. Want to be on the cloud and you want a good VPN system you manage? You take an internet gateway and you get a Cisco VPN concentrator from the AWS marketplace. You can run a Cisco VPN service and your employees connect directly from that to AWS. You can use that same protocol across your 3 cloud providers. If you didn't want to use something made by the networking leaders like Cisco or Juniper Networks, AWS has a service you could also use called Client VPN. And that's basically a pre-managed VPN device that your remote workers can connect to, kind of like a software-based VPN concentrator. And, by doing it, you don't have to manage any VPN concentrators of your own. You have to manage the AWS deal with the AWS one. But you're going to use the AWS device and, it makes it real easy because you're just going to use the AWS thing. So it enables you to, create access control because it's going to integrate with the AWS Identity and Access Management or Active Directory, just like your Cisco router could authenticate with Active Directory as well. So it's going to do what the big providers have been doing for decades. It's going to enable you to create an access control list and a security group for your VPN device. Again, just like the industrial solutions by Cisco would do. And it'll do your monitoring and logging with AWS CloudWatch versus CloudTrail, as opposed to, say, the firewall logs that you would normally connect for your VPN concentrator. And the way it works is you're going to create a client VPN endpoint, and that's what the users are going to connect to. So when we talk about the AWS Client VPN, they got a couple of concepts we'll talk about. The target network, this is going to be the VPC subnets that you want to provide access to through the VPN. The rules, the authorization rules. The rules will define which users or groups can access which networks. There's obviously going to be the client configuration. That's going to be the configuration file that users are going to need to connect to the VPN endpoint. Then we'll create the VPN endpoint. And so that's pretty much it. So how do we set this up? We create a VPN endpoint, management console, CLI, what have you. We associate those target networks, which are going to be the subnets that you want to connect to. And you configure the authorization rules, like in your identity and access management environment. And you download the client configuration. And that's it. So I mentioned earlier with VPC Peering and IBGP Peering that it wasn't transitive. So how do you break it? Well, here's how you break that rule. So if your remote sites or your VPCs are connected via VPNs, we can use something called CloudHub. CloudHub basically is a BGP route reflector that enables you to have a hub and spoke environment where, say, Boston can talk to Washington and San Francisco can talk to Boston through a hub and spoke environment. Now, if you had private lines, you'd use something called Transit Gateway. And again, a Transit Gateway is a router that, just like CloudHub is a router, that's going to enable you to get past those BGP limitations of the transit routing. So CloudHub will enable hub and spoke transitive connections. You'll connect to it via BGP, specifically eBGP. So if you're connecting via eBGP from each location, meaning different autonomous systems numbers, BGP by nature is transitive unless you tell it not to be. Obviously, it's BGP that you're going to connect to, so you can filter routes that you don't want to be reached, for example. Or you could set it up where all VPCs have access to all routing. Routing information, meaning network layer reachability information. But now everybody can talk to everybody. And that's really the secret, is you connect to this CloudHub via eBGP, assuming you're using, assuming you're using VPNs. And by doing so, Sydney, London, New York, they can all connect to it as if it was a normal networking environment. So, but remember, CloudHub is only for VPNs. What if you need better performance, say a private line or a direct connection? Well, that's where you get into AWS Transit Gateway. And Transit Gateway is really like a router, but it's an AWS service that enables you to connect your cloud and multiple environments together in a way that's easy to manage. It centralizes in your networking, so very simple way to do things. Transit Gateway is going to look a whole lot like CloudHub. Now you've got private lines versus VPNs connecting your environments. And it's now allowing your environments to share routes. You've got transitive routing. So the way to really think about Transit Gateway and how it works is to remember it's a router that's used to connect multiple VPCs together. So you could buy a router from Cisco or Juniper or Arista Networks that has done this for the last multiple decades. This is just doing the same thing. Transit Gateway is going to be a regional, highly available AWS network construct, but it's a router. And by doing so, it enables you to do hub and spoke environments versus fully meshed environments and get into that n times n-1, 2 VPC peering problem, BGP peering problem. And that way you don't have to fully mesh your environments. And I showed it a little earlier, but here's another example. In a mesh environment, everybody's connected to everything. In a hub and spoke environment, everybody connects to the hub. So when you fly on an airplane, they use hub and spoke networks as a rule. I use the West Palm Beach Airport. I go to West Palm Beach. I want to go anywhere. I go to Delta. I take Delta to, say, Atlanta, and Atlanta to somewhere else because it's a hub. I want to go to visit somebody. I have to go to San Jose. I leave my house. I go from West Palm Beach to Houston, which is a hub for United, and then Houston to San Jose, that kind of thing. So that's really what we're talking about in a hub and spoke environment. They tend to scale very well. So think of the AWS network, Transit Gateway as, again, facilitating that. So here's how it works. It's going to create an elastic network interface, meaning a network card at each VPC, and which means it's going to need a subnet that you're going to have to put on it. And then, once you connect one or more VPCs to your Transit Gateway, you'll be able to reach each other. So your routing tables will have to be configured either statically or, more importantly, just use BGP to connect them. And that way you can connect your environment, your VPC A's to your Transit Gateway and let it do the routing. So with the Transit Gateway, you can create a site-to-site VPN connection to your on-premise environment or other VPCs. You can peer with other Transit Gateways in the same region or different regions. And a peering with direct connection gateway to where it basically enables you to connect with, say, a private line to on-premise or other clouds. Transit gateways will enable you to create multiple routing tables. They may call it routing instances, and attach different VPCs to different routing tables so you can control where your traffic goes. And only VPCs in the same routing instance can talk to each other. If you think of Cisco and you think of the VRFs, the virtual routing and forwarding interfaces, I think that'll help you actually understand these different routing instance type things. So again, that via virtual routing and forwarding instances that Cisco uses. So why might you use a transit gateway? Well, centralized management, very simple, takes complicated technologies, enables you to go hub and spoke, makes it very easier for organizations that have multiple accounts for security purposes, to connect together. So, that type of environment. It can reduce costs because it's going to reduce the number of connections and peering points that you need to have. It can enhance your security because you've got good traffic segmentation and routing and route isolation you can run between, say, the VPCs that you're talking to. So I think we probably should go to questions. Chris, I think we planned on stopping at 5, so we'll do maybe 10 minutes of questions, and I think I should get people out on time. Can we use one endpoint for multiple EC2 instances? Yes, you can use one endpoint for multiple EC2 instances. And this allows instances to basically securely access AWS services, multiple instances, without needing to use an internet gateway, go through the internet, or use a NAT instance. Good question. Okay. How do interface or gateway? Let me try to understand this. How interface or gateway endpoints link to private? Okay. So maybe this will help. So interface and gateway endpoints are going to be two different types of endpoints. Basically speaking, interface endpoints use the PrivateLINK service, and they connect to a lot of things. And for the most part, a gateway endpoint is going to connect you to basically S3 or DynamoDB. I hope that answered your question there. If not, please feel free to ask more. So, Mr. Gibbs, in order to install our own transit gateway, we get one from the marketplace and install it into the architecture. And how powerful of a virtual machine and network interface card do you need? Well, anytime we're going to deal with any type of a virtual router, we need to truly understand the needs of the traffic flows. So it all depends also on the architecture. So there's one of the big network security providers that is owned by a bigger company, but they have what's called, say, a single threaded firewall or router that they would use. So what does this mean? It means that it's going to need a very high frequency server with a high clock speed, because you can have 32 cores, but if you've only got a single threaded application, it's only going to use one core. So if we're going to use those virtual machines, we need a very high frequency CPU. And there's certain examples of, say, certain Xeons or certain Epic processors that have got very high individual single core performance. And we'd have to specify that. We would also need to determine the amount of routes that we have inside of our routing tables and the frequency that the routes are going to be recalculated. So we're going to have to do that. Now, in order to do that, you're going to actually deal with a network architect who's going to do the sizing in their head. And you're probably going to have some network engineers that are going to run some scripts and do some testing, because this is one of those your mileage may vary. By comparison, if it's a multi-threaded application, we can use more cores on the virtual machine. So there's that. Generally speaking, you're going to use the transit gateway for most of these things that they're actually talking about. Now, if you're going to do a VPN concentrator coming in, that might be another story. You may want to get your VPN concentrator from a Cisco or a Palo Alto network, so somebody that's got big security stuff. that you've got a good relationship with. But Transit Gateway, for the most part, is something you're pretty much going to use with when you want to connect multiple VPCs, etc. Good question there, Prab. Of course, we can go to the next one. And get to the next one as soon as the question's up. It's a lot of work behind the scenes my team does. How many lab questions on their exam? Very few. So here's a secret. And I'm actually going to tell you the employer perspective, and I'm going to give you the CCIE perspective, and I'm going to give you the passing the exam perspective. You're going to have a very small number of questions related to configuring anything in any exam in today's world. It's going to be more on the technology itself. Now let's talk about the CCIE perspective. What if I told you the CCIE, which is the hardest exam in the world, and it has like an 80 or 90% failure rate, and over the course of 30 years, they've only had 65,000 people that passed it. They give you the configuration guide and the instructions when you take the exam. And yet almost everybody fails it. And here's the reason why. Knowing the configuration commands to do it is easy. Knowing what to design and what to configure and why you choose this versus the other one and evaluating on the trade-offs, that's what people hire for. And that's why when they give you a CCIE exam and they give you a complicated scenario to build, and nobody even knows where to begin the building. So there's that. Now I can tell you I've interviewed over 6,000 people in my career. What if I told you that I can find 1,000,001 people that can configure any lab environment in you want? But I go to hire them and I ask them a question like, okay, you want to be a solutions architect. You have a router and it's a virtual router that uses a single threaded application. What type of EC2 environments would you use? How would you determine your say single core versus multi-core performance? Or I ask someone to say, how would you design a demilitarized zone for your mission critical web app? Not how to configure an ACO. So there's that. So there will be lab questions and we'll go over them, specifically speaking, in those free downloads. My team will also do some maybe free hands-on AWS training or some tech training in the week after this is done and the third week. Because I do want you to get hands-on. But we've got a limited amount of time, and I know most people that I've interviewed can't pass the interview. And that's because the interview is based upon what you know. And it's what is the tech, how does the tech work, why you should use it, and it's evaluating the trade-off between various technological options versus how to configure the stuff. That's easy to do. I taught a 6-year-old how to configure a virtual machine or an EC2 instance in less than 5 minutes. But she didn't know what to configure, why to configure, and what she needed. That was the difference. Is there a certain criteria to choose between interface endpoints over gateway endpoints? Well, good question. So let's talk about interface endpoints and their use cases. Interface endpoints connect you to pretty much everything. So you're going to use the interface endpoint except if you're going to connect to AWS S3 or DynamoDB. So you can use a gateway endpoint for that. And if you want to basically use routing table to kind of do your decisions, you might use a gateway endpoint. And it's typically free of charge to connect to S3 or DynamoDB. By comparison, you've got a much more robust setup with an interface endpoint. And this is what you're going to use to connect to most AWS things, say an EC2 instance, SNS, Kinesis, what have you. And it's going to work over an elastic interface. So it basically is going to be very simple to set up for most things. So interface endpoint, pretty much everything. A gateway endpoint, maybe S3 or DynamoDB. I hope that kind of helps. I like that. Is it better to allocate security to the vendor? Well, Pedro, we have to determine what we mean by security. So, I mean, we're going to have a lot of security that we have to think about as security architects. So we have to determine what type of security policy the organization needs. We need to determine what assets the organization is protecting, the value of the assets. We need to calculate what is the cost of downtime to that business. And for example, some businesses lose $1 million a minute. Other businesses can be down all day and they lose $50. So we have to, and then we need to know what is the likelihood or risk of that organization being attacked. And we need to quantify that. We also have to think about what is the brand damage, say, as a security architect, if the organization was hacked. We then have to work with the organization to determine, is it better to transfer the risk, say, to an insurance company, mitigate the risk, or realize they can't afford to do the risk because no business can handle all risks and all threats. We have to determine that. When it comes to security, we need to determine our security appliances. And for the most part, we're going to get much more robust security appliances out of a security vendor like Palo Alto, Fortinet, Cisco, Checkpoint than we would from a cloud provider. It's the difference between a Swiss Army knife and a custom-made knife. Cloud providers do a little everything. Security providers specialize in that. We will have to think about what type of security event management systems we need to correlate all of our logs and all of our analysis. We will need to think about what our demilitarized zones need to look like, what we're exposing. We need to think about our physical security that's going to be going on and what we need to do there. We need to think about our network security, our end-to-end encryption strategy, our identity and access management. So you can't give that over to a vendor. You're going to have a team that's going to have some very competent security architects, and the cloud architects are going to need to know a lot of those. So security is critical, but the type of security and what an organization needs is going to be based upon business needs and business goals. One day I'm going to make a website with my beautiful cat, Cindy. She's like the cutest thing. At least I think she is. But, what are Cindy photos worth on the internet? Not a lot. Let's think about a drug company that's working on a new cancer drug. And if somebody gets access to that information, that company could lose billions of dollars by another company getting it getting it instead. So we have to determine what we're protecting. But security is an executive level responsibility. It is an architect level because architects are executives. It is a business leader responsibility. And I'm going to ask the next one. Do we have a lab for AWS security services? What if I told you that the most organizations are multi-cloud? Most is in 98%. And when it comes to security, it's not going to be mostly AWS security services. It's going to be a multi-security environment. So there are probably some AWS security things that you're doing in some of these labs, but you're not going to secure an enterprise customer with just AWS security or just Azure security or just Google security in 99% of cases. Chris, we go to the next one. Okay. What is a VPN concentrator? A VPN concentrator is a device that you actually connect to. So let's say we've got an enterprise. Pick any enterprise you want. Let's say we've got a global retailer like a coffee company that's got 10,000 locations. A coffee shop isn't mission critical, where if the systems are down for 10 minutes, they're going to lose millions of dollars. At the same time, let's also assume that, the performance of the networking in that coffee shop is not critical. So if we've got 10,000 coffee locations, they're going to use a VPN to connect to the main data center or to the cloud. So if in a data center, an organization may have 50 firewalls functioning as VPN concentrators, where basically the remote user connects to the firewall and creates an IPsec tunnel, and it's a device that does it. We could also be on the cloud, and we could have a bunch of virtual firewalls from, say, Cisco or Palo Alto that we put in our demilitarized zone, and we use them for remote access VPN. So a VPN concentrator is a network device that you connect to connect to a VPN. Good question. Any recommendations for exam practice questions? Honestly, there's lots of good practice tests that are out there. It's not a complicated exam if you understand the technology. And we don't provide this training. For the people that are taught, here's the name of something and here's how to configure it, but they don't know what it is or why it is, for example, it's going to be very hard. Now, I'm also going to tell you that we have another book that actually goes with this course. And inside of that, you may have some exam questions you can use. And it is a book that you can sign up for. It's completely free. Our team wrote it to give it away. And it will also help you prepare for the exam. So go through these videos maybe twice. Do some of the hands-on labs we recommend that'll reinforce certain things. Read that book, and then you can get any practice test you want on top of it. It's really no big deal. Get used to the way AWS asks questions, and you'll pass that exam. It won't be a big deal. How much network concepts should we learn in order to be a cloud architect? And what is the main difference between a network engineer and a cloud solutions architect in terms of the network? So this is a great question. It's a very different job. I'm going to tell you right now, there is nothing in common between engineers and architects. Wait, what? So here's what an architect does. An architect designs systems to maximize business performance. An engineer designs systems to build systems, design systems, performance tune systems. So a network engineer will configure the routers. A network architect will design it. So let's talk about what a cloud architect does, and then I'll go back to to the networking side. You can ask me this question. You can ask David Lithiquim. So here's what we do as an architect. The first thing we do is we meet with the client's executive team and find the goals and vision for their business. If we don't know where the business is going, we can't design a solution. Now, many people skip this step, but I'm going to tell you right now, 70% of all cloud and data center architectures are disasters. They actually don't work at all. Tech works, but that's nothing. So this step is critical. The next thing the cloud architect does, and honestly, the network architect does, the enterprise architect does, the AI architect, is they look at how the organization operates. How does sales occur? How is the product or service managed? What does the supply chain look like? How does the organization get its raw materials? And we need to understand that, because if we don't understand how that business operates and we throw a new technology that changes the way people work, we'll break the organization. Again, many people skip the stage, and that's why 70% of architectures fail. Now, once we know the goals of the business, and then I'll get into the technical side of your question as well. But if we know the goals of the business and the vision of the business and how the business operates, we have to ask that client, how do you want the business to operate in the future? Because maybe they're, say, a global retailer, and they want to know the next time I go shopping at PetSmart for, lollipops for my cat, that I also buy cat beds, cat toys, so they can create a recommendation engine, for example. Well, when I know the business goals and the new process that they want sales occur, I can go work with that organization to create new business processes. The next thing a cloud architect would do would look at the organization's technology. It's AI, it's networking, it's data center, it's cloud, it's applications, it's security, even their voice and video systems. And we ask ourselves, does this actually get the organization to its goal? And if it does, we're done. No new architecture to create it. But if it doesn't, now we've got to go create a team of 15 to 50 people. And we will create a team of network architects and security architects and big data architects and AI architects and data scientists and cloud engineers and DevOps engineers. And we're going to build a team to design a solution that's going to meet that client's business needs, which the architect is focused on the business. Then the architect will create a statement of work. Will determine, what kind of people need. Does the organization have the sophistication? We'll present that solution to key stakeholders. We'll get their buy-in. We'll help sell it to the leadership, negotiate the deal, and then we go off to a new client. So that's what a cloud architect does. By comparison, a network engineer goes on there and configures routers and switches and sets up the IP addressing on the switches and configures the routing protocol on the switches and plans the IP addressing scheme. So completely different jobs. Now, what does a cloud architect need to know? And honestly, I got a free guide on everything you need to learn as a cloud architect. Maybe pop that into the training. I wasn't going to talk about it today, but you guys asked the question. A cloud architect will need network design skills. Wide area network design skills, for example. What kind of wide area network to use? How do you plan your IP addresses? Understanding BGP. The cloud architect will need to understand compute and design, whether you should use a server or like a virtual machine, a physical server, whether you're going to use a container, what your container orchestration should be, whether you use functions as a service. A cloud architect will need to know the storage area networks, things like block storage, object storage, file storage, what they are, how to design them, how to use them. They'll need to understand security design skills. What's your data loss prevention strategy? What's your next generation firewall and DMZ strategy? What's your security policy needs to look like, for example? Some big data design skills, like how do you set up your data pipelines, your data lakes? What types of databases should you use and why? And then, of course, whether you should design a private cloud, hybrid multi-cloud, even AI design skills. Now, obviously, we teach them to our students, but those are the skills you're going to need as an architect. So, big difference. Now, if you wanted to be a network engineer, you need deep knowledge on networking. So, I have 10,000 hours just training in BGP, for example. How do you tune BGP for the internet service provider? How do you tune BGP for the cloud provider? How do you tune BGP for the enterprise? So a network engineer is 100% hands-on techie role. Now, the good news is the cloud is just somebody else's network in a data center. So I'll tell you, I've trained some network engineers and gotten them cloud architect jobs pretty easy, but they have to learn the business skills, the sales skills, the leadership skills, the executive skills, the business acumen, the business process reengineering, the CXO relevancy. So all of us can do it. I got people that I can give you that have been teachers that have been hired, that have been homemakers that have been hired, that were college waiters and waitresses, college students, geologists. Any of you can get any job you want, but you're going to need a lot of networking. Some of that's covered in the AWS Advanced Networking. A lot more would be covered in, say, a Cisco certification, but it's not the how to build. It's how to performance tune and how to design. And that's the biggest difference. One is on how to, and the other is on why. Hope that makes sense. Great questions you guys are asking. I can do one more and then I have to stop, but we'll have lots of time for you guys to really learn. Can you mention some good resources to study cases on to how different businesses are using cloud computing to solve various problems? Well, I can give you the example that 70% of organizations are a disaster. So there's that. So you can't just look at how one company designs their system. If you do, you're going to hurt your next client. And here's what I mean. There's what you call a reference architecture. And David Lithicum and I just created that. A reference architecture is guidelines on how you would set up a provider's stuff. But it's something that you can't use for every client because every client has different business goals. Here's what you need to understand. You need to understand how that individual business operates. I've got two banks and they both do things completely differently. I can't look at how one solved it for the other one. I've got two universities. They have a different way that their students go through the things. I've got one company that does boutique consulting here, but their people need to be experts on this and they need to be extra good at this. I've got another consulting firm that does something completely different. So what you really need to learn is kind of just like a doctor. And I used to practice internal medicine as a nurse practitioner before I moved into tech. I need to learn what is normal. I need to understand business. I need to understand the types of business problems that exist. I need to understand how macro and microeconomics actually affects the business environment. I need to understand how industry trends are going to be in the environment. I need to understand business processes and business process reengineering. And I need to develop the wisdom. So, when we train clients in our cloud architect career development program, we give them various business things. They interview the executive. The executive tells them their business goals, their business pain points, and business challenges. Then they create a custom design, and they got to do what an architect does: document it, present it back, and sell it. So if you tried to sell me somebody else's business solution, you're not going to be there. So the best case studies that I could tell you would be the kind of case studies they use in an MBA program. Learn various business problems. And when you understand business challenges and have the business acumen and education and training to know how to solve these business problems, then you know what to do. But some things you need to be taught. You need to be taught how to fly an airplane. It's not something you're just going to figure it out. And, you're not going to practice medicine and just let me just see what happens. But this is something you just need somebody to show you. I hope I answered that because I really want to help you. So That's what you do. So I really enjoyed spending some time with you all today. I did. We're going to be back tomorrow. Got more networking stuff. We've got geeky stuff for 2 weeks straight. I don't get to talk too geeky anymore because when I moved into the executive architect roles, I had to be more of an MBA than I got to be when I was an engineer. For those first few months that I was an engineer, I moved straight into architecture roles. It was the best thing that I did. But all these roles are great, and everybody is needed. We need everybody to make it work. It's just about finding the role that resonates and sits with you. And I like to get geeky, but I don't get to do it too much. So I'm thrilled to be here. You all give me a hashtag AWS Solution Architect Associate so I know you're here. You can go back and watch this video again tonight if you want. It'll be stored on our YouTube channel. I love training people, and I want you or any of your friends, relatives, brothers, sisters to be able to go back and access this content. We will leave it on there, and it will stay free for you all. Super nice. I'm thrilled to see some of these comments in there. Please download those free resources, do those labs, and this gives us the ability to maximize your time. And then after this is work, we'll even have some free mentoring sessions with you with our team. Love seeing all this AWS Solutions Architect Associate. Adrian's AWS Solutions Architect Associate. So Pierre, I haven't seen you in a little while. So good to see you. AWS Architecture Rocks. Thanks so much. It's good to see you. AWS Solutions Architect. This is what I love seeing. Oh, it's good to see you, Kingsley. And we're so happy to provide any opportunity we can.